So you will be able to replay it at home. Typically, it takes about a day or so for the Zoom to like it's built into the cloud recording and send us a link. And once it's set, Herschel will send out a link to all of you. But essentially what we're going to focus on is understanding the entire software development process, because the quality is kind of ingrained into it. And we'll talk about what the quality assurance is, what are the different terminology people use it while doing the testing and quality assurance. We'll utilize some of the tools, right? Not necessarily all of the HP tools. Starting last couple of sessions, Herschel have decided to start utilizing what our more cloud-based tools are, because that's what we're seeing in most of the companies already shifted at getting into the cloud-based testing tools. Okay, and then we'll do everything from the real life project. So we'll kick it off with a project today that we'll go through the course, and then we'll also give you an additional project as we come towards the end of that to do a lot more practice on it. Okay, and those projects are the real life projects, are the ones that like it's Herschel and we have worked it with some of our clients. Okay. So what you're going to do at it's when you get into IT field, right? People will throw a whole bunch of terminology at you, right? There's a whole bunch of jargons that people in IT like to put it together. Okay, this is one of such slides. Okay, here are some of the tools and technology that we're going to go through it before the end of the course. Okay, so let's start with it. Let's first focus on actually what is the software, right? When people talk about that they want to do it, software development and so on, let's start with, is that coming in the center? Yeah. Okay. What we're going to focus on it is essentially talk about what is the software and how it's built. Okay. So let's talk about what is the software. Okay. Anytime if you have any questions, please stop me. I like interactive, right? I don't get hesitant when people ask questions. To me, that's the way to see it. Is if not clear to it, raise your hand, talk about it. Okay. So here's the definition, what you're seeing on the screen, as defined by Wikipedia for what is a software, right? It's essentially nothing but a machine readable instructions that essentially feed into some sort of computer that essentially is an output, it performs the specific task. Okay. Simple example, right? Everybody has a phone in their hand, right? You take the picture, you edit the picture, you share the picture, right? Nothing but a software. Okay. You're giving specific instructions to perform the editing or sharing the pictures. Okay. So why even bother learning about it? So how many of you have a smartphone? Raise your hand if you have a smartphone. Right. It's not a single person nowadays. I'm going to get it hand raised. Even if it's somebody who is going into the middle school, they all have smartphone. Right? Nobody uses the normal phone or anything screen and that. Okay. So what you're going to see, irrespective of where you go in life, you're going to have some sort of software interaction. Smartphone is one example, right? Anybody it's perform any search on any of the devices, right? Whether you use it nowadays in your smart TVs, right? Plug it, you search it, whether you're using Netflix, Hulu, whatever your favorite streaming choices are. All of them are nothing but a software. Okay. Take it, the commute, right? Everybody transports it back and forth. Most of the cars now getting into where it is a lane assist, right? Or it kind of give you a collision alert, cruise control. All of those are nothing but a software driven things. Okay. No matter where you go in your life today, in the current world, you're going to interact with the software, irrespective of where you go, whether you want it or not. Right? So when you think about it, it's an indispensable thing in our life today. Okay. So a lot of times, it's when people initially, it's when software came out, they think about it is you provide an input, you perform some calculations, and you get some output. Fundamentally, that is still true, irrespective of what software you use it today. Okay. Whether you take it from a calculator or You take it as self-driving cars, right? All sensors are providing input. It's making a decision, how fast and which lane it to drive it. Okay. All of them is talking about productivity. Uncle Sam is going to come soon collecting the money, right? Herschel and I were talking about soon. Uncle Sam's due dates are going to come up, like it's April 15th, before thing comes in, right? All of us use some sort of software, right? Whether it's a TurboTax cloud version, or you go to your CPA and then they just create it. And then most of us file electronically nowadays, right? Electronic is nothing but a computer way to communicate back and forth and get information. Whether you do research, right? The kids and adults, gamers, right? Xbox, PlayStation, pick your favorite choice. Okay. One of the example I talked about, processing pictures. All of them is requires us to learn on that. Okay. So what is the software? Okay. Let's talk about that. Let me see it. If I can get the draw up. So when you think about it, any computer, I want you to think about a box. This is too thick. Do we have thickness, Herschel, on this one? Yeah, that's. So when I want you guys to think about a computer, it's essentially a box, right? The box is made up of something known as hardware, right? So let's use our phone as an example, right? The physical feel and touch that you see, it's essentially nothing but hardware. Okay. On top of that hardware, you're going to see it's something known as a system software. So predominantly, right, either we're using an iPhone or an Android phone, right? So if you're using an iPhone, iOS is the system software, and you need to have that. Without that, you can't operate an iPhone. When you think about it, any other Android phones, you need to have an Android operating system on it, right? So a lot of times, this is also known as an operating system or OS. You'll see it in IT. We like to use abbreviation or acronym for everything, right? So what the purpose of this is, essentially, they communicate with the hardware through something known as a firmware. Okay. So it's a small piece of dedicated software running on the chips, right? So if you had to, like it's pry open any phone, it'll have a whole bunch of chips in it, right? Those chips, essentially, some of them contains the firmware software. Okay, which essentially tells the phone what action needs to do it, right? So for example, when you dial somebody's phone number, right, it takes that information and actually converts it into the radio waves and send it to the tower. That's how the communication happens. Okay. On top of system software, there is something known as an application software. Okay. So this is a portion that you can add on top of the system software to enrich and create some of the productivity. Right. So these are the productivity applications. So let's take a very basic example. Okay. You want to send a text message to somebody, right? On the phone. All of you have done it, right? Send a text message to somebody. So think about it, how it works, right? So when you want to send a text message, what do you do first thing? Open up the application, right? Through which you want to send a text message, right? That application is the application software. Okay. When you do it, what is the first thing you do it? You can say, hey, here is the person whom I want to send the text, right? So you select the contact, whatever you want to do it. Then what you do is you type in the message, right? And what you do, you click send. What happens is when you do that, the application software communicates with the system software saying that, hey, I need to send text message to this number. Okay. System software in turn understands it and says, you know what? I'm going to go ahead and let the hardware know that this needs to be sent, right? So it talks through the firmware to tell it. What it does, it needs to know exactly how to convert those messages into the specific instructions, right? And that instructions is going to be dependent on the hardware only, because it needs to convert that message into some sort of signal. Obviously, like it's when you think about it, the text message that you send it, let's take an example. You're sending a message through WhatsApp, right? Works on both the platforms, whether it's an iOS or Android, right? All it cares at is, can I communicate to the operating systems? They don't care that from what are the phones and how the signals are sent it out, right? All of that thing is system software says, hey, I need to know what hardware on which I'm running. So what kind of specific signals I need to generate it so that it can send it and communicate with the cloud. Okay. And once you get the response back for that text message, right? Whenever you send a WhatsApp message, right? You get some sort of an acknowledgement. Somebody reached it, they've read it, right? By through the different coloring ticks, right? So whenever that response comes from wherever it is, hardware takes that, converts it, and sends signals to the system software, which in turn recognizes those and delivers it to the application software. Okay, so that's how, in a nutshell, most of the software works. What you're going to see it as the bottom layer. A lot of times it's known as a computer platform, right? It will say, hey, what is the environment, right? We'll say it's an Apple environment or Android environment. Whenever they refer, they usually refer the bottom two portion together. And then the top is the application software. Most of the work, and I would say it's with fairly confident degree, about 99.5% of you will always work only in the application software domain. Okay. Unless you are working for a firm which builds a dedicated hardware in a software systems on top of it, most of the testing that you will do, it will always reside in this one. Most of the quality assurance work you're doing will be developed and focused on application development work. Unless you are working at Apple or Android or Linux or to some extent at Microsoft, you're rarely going to get into the system software layer. Yes.
Could you please explain what exactly is firmware again?
So when you think about hardware, okay, everything is sent across the world in bits and bytes. Okay. So everything gets converted at the end of the day into signals of 0 and 1. Okay. So essentially the firmware, when I write a text message, right, how does it get converted into zeros and 1? System software just converts that in what is known as machine language and sends it to the firmware. Firmware knows exactly, based on the instructions that I get it in a machine language, which hardware to trigger to generate those zeros and ones, and what sequence And what message gets converted into 0, what message gets converted into 1, right? There are whole sets of industry behind the hardware, right? So you mentioned you worked in electronics, so you know it, how the chips, digital chips, everything works within that. That's what this is about. I wanted to put the firmware because just in case if somebody throws a word at firmware and everything, you need to know what it is. As I say, you're going to work only in this domain. Very, very few of you is going to work on this domain. Right. I'll tell you, I have electronics engineering and masters in computer science and computer engineering. There were like 3 or 4 courses I had it. I did some digital designing and actual hardware working in my undergrad. There's been a few times I worked on this. Almost all of my work is kind of centered around here.
Yeah, pretty much all the companies like AEP, Nationwide, anybody who builds the software now, they all are application software.
Yeah.
You will practically never work it in collaboration. I don't think I have seen.
Yeah, think about it. So the only time if you work in Tesla and GM, right? So GM just announced it day before yesterday, they're going to shift it 30% of their vehicles to electronic vehicles before the end of the decade. Right? That means they're going to get into hardware. They're going to get into, they already have a specific OS, right? So when you think about it, the CarPlay in a car OS, right? That's already getting plugged into the system OS. So most of the work that you're still going to do it, it's still going to be here connecting to it. But there will be few engineers who will be just saying, hey, how do I make sure the battery triggers in when some event happens? And only those guys are going to work at this level. Okay. Any questions understanding whether it's online or in the classroom in terms of what are the layers and how things work in a computer world? And this will be true irrespective of what hardware, what work you do it. Even if you like it sending it rockets to the moon and Mars, you're still going to do this 3 layers, irrespective of where you go. Okay. So we just talked about, right? System software versus application software. The middle layer versus the top layer in that diagram. What is a system software, right? We talked about operating systems, Android, Windows, the Mac OS, iOS. Its responsibility is mainly coordination with the hardware. On the one side, in the software, which is the application layer on the other side. So it's an intermediary. It translates essentially the higher level languages, what is known a lot of times as 4GL and 5GL languages, right? 4th generation language and 5th generation languages into the hardware or operating system machine codes. Okay. A lot of times when people talk about computer platform, it's essentially a combination of hardware and an operating system running on top of it. Okay, let's talk about the application software. Now, a lot of times people ask question, how do I know whether something is application software or not? To me, it's as simple as that. Can you run the machine without that software or not? If you can, then it's an application software. If you cannot run the machine without that software, that means it needs to be an integral part of it. Right? So that's the simplest way you can define and delineate 2 things. Is something that I can add on top of a platform to add a productivity, then it's an application software. Typically in olden days, we used to have something known as a hard drive or flash drives or CD-ROMs or network that you do it. Nowadays, most of the things is kind of transitioning into the network, whether it's cloud or remotely accessible or not, right? So think about it as when you boot up your laptop, right? Whatever you need to boot it up, like the simplest example is Chromebook, right? Some of you have an exposure to the education systems, right? So when you go to the elementary school and middle school nowadays, right? Kids use only Chromebook. right? And those Chromebooks are fairly thin, lightweight, right? Doesn't have any software on it. All it does is boot it up, the Chrome OS, works it, and then you connect to the network to do whatever the work you need to do it, right? So all of that work that they connected to the network to do it, whether it's a cloud or Google Drive or one platform, whatever they're depending on the school system that you're using it, they will use all of those platforms, right? They all are nothing but application software on top of it. Now, when you go in the real world, right, just like all those application software, it's essentially nothing but increases the productivity. Be it your image processing, like it's you taking the picture and editing it, sending it to somebody, or do it as simple calculations, right? So if the kids in the middle school, right, so you fire up the calculator and start using all those algorithms and everything. Still a productivity software. Most of us, including me, what I'm doing right now is presenting some sort of a deck or material to all of you, right? Nothing but a software, right? Productivity. It's I build something that I want to present and make it visual to everybody. That's the software. Okay. The whole purpose of that is they typically work with the system software to tell the computer what productivity task they want it to perform. Okay. Any questions before we get into the next layer of the application software? Okay. So when you go in the real world, you're going to find the various categories of application software, right? And one way to categorize the application software is by its usage rights. Okay, and then how it was built. So when the first one you can think about it as a proprietary software. Okay. So when you go out and try to buy any software, it's going to be built by somebody, right? In the case of proprietary software, it's a software that works only on a specific application, on a specific hardware, and it's kind of built and owned by a specific company. Let's give an example. Okay. Tesla. If you buy a Tesla car, right, all the software that on it, which is written it to essentially manage the car or to communicate it, it's built by Tesla, right? You can't just say, hey, you know what? Let me go to GM, buy a software and plug it and install on the Tesla and expect it to work. It's not going to work, right? The ownership at that point is with Tesla, right? On the flip side, same thing if you're going to use any of the other automobile, right? Whether it's Toyota, Honda, GM, irrespective of where, right? All of the software that they build is proprietary is for that particular hardware to control that particular machine, and it's going to be owned by that particular company only. Flip in the world of phones, right? All of the iOS, everything is owned by Apple, right? You can't take an iOS and say, I'm going to drop it on an Android platform and expect it to work, right? When you buy a phone, right, it clearly says that all of the software, including the proprietary work, is Apple's. You can't rip the iOS and put into the other software. Same thing with the Windows, right? Windows is designed and tuned to build in that, and everything is owned by Microsoft. Okay, that's one example. The second set of software you're going to see is what is a lot of times known as off-the-shelf software. Okay. This software are typically kind of build it to run on the multiple platforms. Intention to, like, you can put it on the shelf, somebody can purchase it and install it and work it. Okay. For example, so I talked about, right? Tax season is coming up. So you take a TurboTax, right? Or H&R Block, right? The tax cut software that comes in. You can just go to the software. I'm sorry, go to any of the store, buy that, bring it to your home, install it on your laptop, irrespective of whether it's running it a Windows platform or a Mac OS platform, right? You may have to buy a specific version that is kind of more tuned to the MacBook or to Windows platform. You can install it, works just fine, right? It's off the shelf software. Another example, I talked about WhatsApp, right? You can just go to the Play Store or Apple Store, just download it and work it, right? It's the same software, they just build it and say it's going to be 2 stores through which it's going to be available, right? It's off-the-shelf software. The ownership is still potentially with the company, right? They will still sell it, they will still make the money, they will still charge you for building the software and selling the software. It's like any goods you buy. But it works on a multiple hardware. It's not tied to a specific hardware. And then it's not that you can make enhancements, right? You can make a whole bunch of enhancements on top of it. For example, Microsoft Excel, right? Some of you who have been kind of having your own business, you can extend by putting additional macros on the Microsoft Excel and then keep enhancing it. Okay. Third type of software is known as open source software. Okay. Now, the first 2 software is always built by some company. The next sets of software, open source software, it's essentially built by a community of developers. Right? It may start as what's sometimes known as a proprietary software or off the shelf, and they make it an open source. Okay. What the open source software is essentially, you can take that software and you can modify for your own personal use to do whatever you want to do it, or you can build services on top of it. Okay. As long as you make it and follow certain rules. Right. For example, you will see hear a lot of words like a Java platform. Right. When you come to the IT world, one of the platform that a lot of developers use is known as a Java platform, which is a 4th generation and 5th generation programming language. That is a community-owned thing. Right? You can take the Java software, you can enhance it whatever you wanted, and apply it to whatever platform that you wanted to use it. Okay. Another example of the open source software is some of you might have used it. Yes.
So just want to make clear when it comes to these terms. So when you say platform, is it the same thing as same tools, or those are 2 different things?
Those are, depending on how you use it, it's a different thing. When I say platform, what I meant is the bottom 2 layers, hardware and a system software. That's what I call as platforms. The tools could be something you drop it within the system software layer or an application software layer.
So, I mean, the reason I'm asking that is Agile a platform or a tool?
Agile is a framework. It's a completely different thing. I would not even consider a platform or a tool. It's a mindset in my mind. Okay. And we'll talk about it when we go in here with a little bit later. But so hold on to that when we come to that. If it's not clear to you, let me know. We'll talk through it. Okay. But essentially, when you say it's open source, it's essentially, I don't have to pay somebody to use it. In the first 2 cases, I should be paying somebody to use those 2 things. Right? Either they explicitly give me, hey, it's your 30-day license, you can use it for free. That's still a proprietary software. It's still off-the-shelf software. Open source says, I'm not limited by time. I can use it however long I want to use it for my personal use. Okay. Another one you're going to see it is Java is a software development platform, right? So when the way I say it's platform, it has to run on some sort of hardware and it is its own operating systems. Okay. A lot of what I call it is Internet of Things, which is your devices, right? Whether it's kind of a watch or those things. A lot of those things are powered by Java, IoT devices. Okay, but the other one is Linux operating system. And so the big firms use what's known as, just like what you have with Windows and MacBook. Linux is usually the operating system which powers your enterprise service. Those servers are it's nothing but those are an open source software. If you are it's a lot more into it and you want to dig into it, right? How many of you use some sort of a Facebook or Instagram type of software? right? It's a worldwide software, right? Think about billions of users. Can't connect it billions of users to one computer, right? It has to be in a distributed platform. That entire operating system, which manages the entire Facebook's distributed platform, is an open source. It's a very complicated one, but if you like it, you can get into it and modify it and use it for your own purpose. Right? But that's the level of open source software that we're talking about. Okay. I don't know if any one of you use, like most of you use Microsoft Office, right? Typically, there is an open version of similar thing called the Open Office. That's an open source software. You can just go in and grab it. All of those that are freeware softwares. Okay. Any questions on those things before I move into what is known as an architecture world? Yes.
I would like to have an example of the property software.
So,
So anything that we built at.
Yeah.
Companies.
so think about it.
Chase banking application, I mean.
Yeah, I can use some of those. I'm restricted from using it.
Well, I'm sure they all.
Let's talk about, right? So. The other examples of, okay. Do you use TVs? Smart TVs at home?
Yes,
What kind of TV you use?
I have a Samsung.
Samsung, right? So Samsung has a whole bunch of software that they install on all of their smart TVs, right? They're nothing but proprietary software. It's owned by Samsung. You can't pick it up that software and install on other devices, right? So Samsung has like smart hub, right? That's what like as soon as you power Samsung smart TV, it comes up with smart hub. That's their proprietary software that essentially communicates back and forth with the Samsung network and Samsung devices. So that's how they push it. Any of the system updates that you need to do it, right? Occasionally just keeps circling and updating that. They're nothing but their proprietary software. Okay. Another example is, as I mentioned, right? Tesla, right? So Tesla's navigation systems, that's their proprietary software. You can't pick it up on your phone and use it.
So the projects you will be working in that platform, they are technically in the
Proprietary software.
we build for our clients, which is only available.
Yeah.
For the client.
So think about it, it's a one-of-kind program, right? So you can't just go and like plug and play it for somebody else. Right? You can still do a plug and play on off-the-shelf software, but not on the proprietary software. As Harshal pointed out, 80% of the software that you're going to build it's going to be proprietary software for both firms. Now let's talk about the software architecture. Okay. So we talked about the three layers, right? Like application layer, system layers, and the hardware. What I'm going to talk about the architecture, typically you can apply to the middle layer also, but mainly I'm focusing on the application software layer. Okay. So all of you, like live in some sort of homes, right? When you talk about home, you can't just go and say, hey, let me just go and put all the wood pieces together and build a structure, right? There has to be some sort of thought process behind it in terms of how you want to lay it out, right? So what do? You start with some sort of a blueprint, right? Whenever you want to build a house or any of structure, you start with the blueprint. The blueprint, essentially, it's nothing but talks about what is the architecture of the house is going to be, right? So it talks about, hey, how all the systems is going to fit together, right? So essentially, what is going to be the dimensions, right? How your frame is going to be laid out. And within that frame, how the electrical system is going to work through it, how the plumbing system is going to work through it, right? And then how you're going to put a structure on top of it, right? What is the purpose for each one of the structure, right? So when you put specific things on the foundational frame, right? The whole purpose is, it's gonna essentially take care of all the loads that is coming in the house, right? Versus when you're putting something of like a drywall, right? It's not supposed to take the load. It's supposed to like essentially give you isolation from one environment to another environment. Right? So those are the kind of elements that you think about in architecture, right? So when you plug in a frame and then you plug in electrical system to it, there's some reference, right? You can't just draw and pull the wire from anywhere that you like it, right? There's some structure that you need to put it. Now, things gets even more interesting if it is like it's more than a one-story house, right? How you going to build the other one? When you build the other one, how actually all of the heating and cooling elements connects it from the first floor to the second floor, to the ground floor, wherever you put these systems, right? So there is some purpose for every component, but there is also how that component interacts with the other component to give you the holistic view of what is the comfort level you need to live in the house for safety, right? So for example, I have a plugs here, like the switch on off and a plugs, right? They're connected, right? There is a specific interface of how they connect it. And when I turn on the switch, it's supposed to expect to do certain things, right? That's nothing but a home architecture. Software is built a similar way. Right? So when you talk about a software, it's nothing but a various components, which each one of them has specific purpose and specific role and functionality. They come together, but when they come together, you need to identify how they're going to interact with each other, what will be the interface for them, and what is the holistic purpose that they were doing. Okay, but essentially, so when you think about it, computer architecture is nothing but a set of structure, right? That comprised of software elements, right? Individual components, right? So when I'm building a house, the frame, right? The 2x4s, the wooden frames are nothing but one of the elements. The drywall is another element, right? The electrical wire that coming through it and going into the plugs is another element. Okay, the relationship between them, how they connect together, what the purpose of that, and the properties of both elements and the relationship. That's nothing but at the end of the day, it's software architecture. Now, what are the different software elements? We'll talk through it as we go through it. Right. One of the perfect example that I give you is think about Legos, right? Either we played as a kid or we have kids that play with the Lego. Right? Legos are nothing but an element. Okay. Each element. So when you try to build something on a Lego, right? Take a basic building block. That's an element, right? But it also have an element of what is the relationship. So there is a specific interface, right? You can't just simply connect it without that, right? So it has a specific round circles, right? Which is the interface that allows you to connect with the other Lego element. And when you connect it, that becomes a relationship between those two elements, right? That's what this is. Okay. And then the properties, right? Certain ones, like it's when you say it's like 4x8 Lego elements, or 2x6 or 2x8, right? They each one of them has a specific purpose. If you're trying to build a Lego structure in a building, right? You're always going to look at it. So you're going to look for the one that has a broader responsibility, the broader connectivity, always as the base, right? And a smaller one you tack on top of it as you build that element. Right? So each one has properties. And then as you build them, it has a relationship in that. Think of it, the modern day software is also like you're building a little different Lego blocks. Each has a purpose, and then each is kind of connected together. So let's go back to the text example that we talked about, right? I want to send a message from my phone to somebody, right? Think about it, the various plugs comes into it, right? I'm going to fire up my application that opens up, right? It is going to connect with the context so that I can pull up a context from my existing contact list, right? That's nothing but a relationship, right? I build an application, I build another application. And then they have ability to connect with each other. So my overall functionality, when I'm trying to say, hey, I'm going to send a text message, right? I needed an application, but I also need an interface of who the relationship is. Also, then I need to think about the hardware, right? When the actual message is sent, I need some sort of confirmation that it was sent and received, right? So there are various elements that comes together to give you that overall functionality. Good. All right, now let's look at the various architectures, right? So the earliest forms of computers, if you think about it, goes back to 1920s, right? So it's almost 100 years ago. If you look at it, I'm a kind of person who tries to relate to things to understand things better. Okay, so if you think about it, how the humans have evolved over centuries, over thousands of years, right? They essentially enhanced their living patterns or the environment in which they live it over the years, right? So probably I would say it's 5,000 years ago, how the humans were building houses was completely different, right? They will probably like find a cave, make sure that cave is kind of protected, and then just build it living around whatever is available in that cave. As things evolve, right? And they've started putting together the mud houses, right? So that they can build a structure around it. Then it just became said like stone houses middle of the time, like to the multi-story structures that they've started building in the 18th, 19th centuries, right? To now, when you look into it, it's completely different houses, right? Also, they adapted based on the geographical environment, right? So if you go build a houses out up in the northern region of Canada, it's going to be different than the way that you build the houses in probably the tropics, right? So, but again, even within that, things has evolved over time, right? Same thing with the software world, right? The way the software was built over 100 years ago, it's kind of a different than how software is built today. Does that mean only one architecture is right versus the other? No, there's always going to be in that some of the systems or houses that you build it, right? If you walk around it, like there's 1,000-year-old houses. There are 100-year-old houses, right? The house is still safe. Some of the 100-year-old houses are still functional and livable. Right? 1,000-year-old houses, I'm not sure, but the 100-year-old houses are still livable and functional. Right? Same way in the software world, irrespective of where you're going to end up, you're going to still see some of the old architecture and some of the new architecture, and you still need to figure it out how to interact with them and then how to work with them. So the first one, okay. Back in 1920s, 1930s, when things started, it started with what is known as a monolithic application architecture. Okay. Where everything was in one place. Right. Typically, like it's when you look in any software world, like what we talked about is anything what you're trying to do it. Let me see if I can go back to here. Okay. So any software world that you think about it. Okay. All you do is provide some sort of input, right? Perform some sort of processing, and you provide an output. Okay. So anything which you provide an input and output, it's a lot of times when you think about it, it's the data, right? Let's take an example of calculator, right? I want to do 2 + 2. Right? What is my input? Data, right? 2 is data. Another data is operator, right? What operand I want to use? I want to use an additive plus. What is going to be my output? 4, right? Again, data, right? And then the things that we actually adds those two numbers, right? 2 plus 2, it's a code, it's a process, right? So a lot of times, everything that performs the processing, it's known as a code. It's the logic, it's the instructions that are telling computer what to do, right? So in the olden days, all of the data, the input that I give it and output that I get it, and the logic that I use it, it's all bundled up together. Okay. If you want to see a real example, right? So in the early 1930s, when the IBM built the first calculator, right? It was like 2 floors. It was like that big, 2 floors, and all of the data is going to be in there. I'm also some sort of science and history buff, right? So have you guys ever seen a movie called Enigma? Okay, if you get a chance, and if you're interested in science, look at that movie. That movie is centered around Alan Turing, who actually built during World War II a machine to decode all of the encryptors that the Nazis were using it to send it. Right. And the Nazis will change it every 24 hours, the logic that they're using it to encrypt the messages and send it out to the field. So it's a movie about a person called Alan Turing, which a lot of us still believe it's father of the computers, right? Because he built those state machines. So Alan Turing, and that actually it's a movie about him building a machine that essentially you take it and give it an input to it. So essentially one of the encrypted messages coming out from Nazis. You run through it and then get it right there in output of what that message is meant, so that they can actually decipher, and then the allied journals can actually look into it and says how they're going to deal with the Nazi threats. Okay. That's a perfect example of all of the code, all the big machine that he had, it like 3-room big machine, has all of the code in terms of levers, and then all of the data. You input the data through certain mechanism, it's all into one place. You cannot distinguish. If you want to use it, you have to physically go to that location, provide that essentially data into that segment itself, which is integral with the code, and you get it everything into one big piece. That was the original computer architecture through which it evolved. Okay. That's how most of the insurance companies started with calculators back in 1930s and 1940s. Okay. As things evolved, that investment on that particular big machine was so much, it cost multi-million dollars in those days. They said, we got to make it a better use of that. So they started evolving and thinking around it, the engineers come together, and then they built something known as the client server architecture. Okay. In this case, they say, hey, there's going to be a main thing which is going to perform all of the computing power. But when you look at it, right, a lot of times it's an idle. What if I can, like, it's provide multiple inputs and slice them so that for certain period they're working for this and certain period they're working for this, and then I can quickly slice through it. Right? So instead of 24-hour dedicated to one task, you can say, what if I can, like, it's break it and says that machine is going to be dedicated to 24 tasks and 1 hour each task. Okay. And then as the servers are a lot more faster than the humans of our process it, you don't need that. You can create the slice for first few seconds, I'll work for this, next few seconds, I will work for this. Then the next time slot will come back, so that essentially I'm kind of thinking about, I'm serving all of them at the same time, but through a very fine time slices. Okay. In this case, they just says, hey, you know what? All the requests is going to come from a remote that they will now send a request to the server. Server takes that, processes, and sends back. Okay. Same thing they will do with client 2 and 3, with the notion that all of these things doesn't require 24-hour request and task. Right, so now I can keep this guy busy 24 hours and can serve multiple people. From a bank, from a insurance company, from a commercial firm, that's much more useful now, right? Because they made an investment in this. Now you can have multiple people use that. Okay. However, this kind of architecture starts bringing complexity. Because now I have to worry about here. I never have to worry about, hey, what data and who is requesting? Because there's only one set. Right? So there's no confusion who's getting what. When I go here, I want to make sure if this guy requested him something, the response goes back to that person and not to the other client. Right? So now my complexity of software is going to be a little bit higher because I need to keep track of who's requested what. And I need to make sure I respond. But there's also, what if the request comes in and before I send response, my connection is lost and that guy goes away? What do I do with that response? Right. You see how the complexity now adds? Because it's not in one box, now it's across 2 boxes. Think of it like it's when I turn on the switch, I want that particular plug to go on. What if it doesn't happen? What happens? Right? Or if somebody removes that plug and the turn on switch on and off, what happens? I need to start thinking about those scenarios. What that means is if I'm testing a software for this, now I need to start thinking about those scenarios also. Not just the functionality, but did I get it back response to the right person? And if I didn't, and if that person doesn't exist, what should I do with that? I have to test all those scenarios, right? And all of this are networked, right? What happens if I lost the connectivity and then gain back the connectivity? What happens to my request then? It may be very easy, right? If the client goes away, discard it. But if client went away temporarily and came back, now what do I do? Right? So as we go through this client server architecture, it provided a benefit, but added a complexity. Right? Provided benefit, now I can be used by multiple people. Right? Complexity is I had to worry about all these things too. This was the architecture that came in like it's around 1950s, 1960s, where they started getting into a more broader use of computer. Okay. Then came it around mid-70s, early 70s, where people started thinking about more widely use of computers. And then all of a sudden they realized that yes, what is the most intellectual property for any company? It's the data and the customers, right? It's not the hardware, it's not the physical machine. You can replace the physical machine. It's the data and your customers important. Then they started realizing, hey, I need to start thinking about data as a separate aspect. And then the processing. Because here, when you look at it, the data and everything was still centrally, right? It was one. What if I have multiple servers? Then my data is not shared across. Now I need to start evolving in this that more the servers I have it, they may just want to utilize the same data because my customer base is same. Right? So that's when the data tier came in. Okay. So in mid-70s, as the proliferation of the computers started coming into more corporate world, they started to say, I have to protect my data separately. Then the business logic. Right. So take an example, right? If you're a customer of bank ABC, right? All of the applications, like whether you want to add, like it's deposit, withdraw the money, that's nothing but a business logic, right? The data is actually, what is your account number? How much balance you have in the account number? What all products you have with the bank? That's all of your data, right? How you manipulate the data? It's going to be business applications, right? So some company allows it, because if I'm like it's doing a trading, right? Some mortgage firms allows me to take the money and trade it only as long as I have some deposit or some security. Right? Some allows you to margin, says, you know what, I'll allow you to borrow it. Right? That all application logic lives here, but the actual amount of the data and what products I have, it is in the data too. Now, the way that it presented, now they realize it, right? So you have a client now. Here, it was very simple, and I don't know how many of you have seen an old movie or not. Actually, I have seen it physically, not telling my age, but I've seen physically green terminals. Okay, when you go walk into the bank, walk into any of the big companies, they used to have a green terminal. Okay, if you ever see movie Ghost, if you see it, that they have some example of green terminals there of how they process it. Right? It's a one and same standard. It's an 80 by 25. So if you like look at it, how come a lot of old screen has 80 character width and only 25 things in a screen? Because that was the limitation of green terminals. That is the CRT tubes that was built on them. Okay. But as it came in, all of a sudden I have proliferation of my end devices. It's no longer green terminal, right? This is the time when Windows came in. Right? This is the kind when, like it's MacBook, the original MacBook came in, Apple Mac. Okay, so now my screen is no longer limited to same size. It's going to be a different form factor, right? So now I need to think about it is I'm taking this data, applying business logic, and displaying it on a different size of terminals, right? So, but my business logic is always the same, right? No matter how many business applications I have it, my data structure is behind the scene or utilizing the same data. So now I need to worry about 3 different tiers, how they come together to present one value to the customer. Okay. Now the complexity starts involving a little bit different. Okay. Earlier, on a client server, I have only one connectivity. Now I have 2 connectivity. Right. Customer coming into the application tier, what if this application is not available? I have to deal with that. Or if a customer goes away or what kind of query they ask it, I need to think about it and give them the data, but then that data needs to be presented. They need to know what kind of devices they're using it, whether it's a mobile device, it's a tablet or a PC or a green terminal. I need to mold my output to meet that. And then my data tier is going to be, what if it's available or not? Right? So the complexity adds it. So now if I'm doing a testing or quality assurance, I have to worry about all 3 layers, availability of all 3 layers, changes in behavior at each one of those layers. Right? See it, how the complexity now added for software development. Benefits are there, right? Now I can access irrespective where. So this is the example where people said, hey, I could call and get my banking done over the phone instead of actually physically walking into the branch and do that work. Right? I could go to ATM and withdraw the money instead of waiting it to go to the bank, which is open only certain time period. Okay. So those things started coming into play. Then came 1990. The likes of the world of Google came in. Okay. Or the Amazon started building it out. Now, when you look at it, right, in this scenario, earlier in the 70s, 80s, typically your customer base was not global. It was local to whatever the physical location that you are, right? So typically it will be limited to the people who can call it or people who can walk into your bank or in your business and then do the work with that, right? So the amount of the people that I had to probably serve at any given point was in thousands only, right? So my compute power and everything was kind of limited to that. I didn't have to worry about too much on it. I can fire up 5 servers together, connect them into a network and address that and I'm still good. Okay. With the internet, the whole thing changed. Okay, now my customer base is not just limited to local, it's coming global. With the Amazon came in, things started coming in into this. I'm not having hundreds of thousands of customers, I'm going into millions, right? Take example of Black Friday. Like, how many customers actually hit the site on the same day on that same time, right? When you look into like it's things like Chinese New Year or the Amazon on a Black Friday, the amount of the transactions they do at per second are in millions. Right? That means I have millions of customers. So there's another dynamic concept play. Okay. Let me talk about it, a little bit about the hardware. Okay. So let's see if I can. Okay. So let's talk briefly a little bit about the computer architecture of how things works and what the memory comes in. Right. So have any one of you actually went and looked into if you want to buy a computer, what kind of specs are the things that they look, right? So there are multiple things that when they talk about that, hey, you want to go buy a computer, right? You look into it as how much powerful is the computer, right? So typically you look at the CPU, right? And say it's what kind of CPU it has, right? What kind of processor, how fast processor is, what it can do it. Then you look into the second number, which says how much megabyte of RAM or gigabyte of RAM it has, right? And then the last one says, hey, how much is actually the storage space it has, right? Have you ever wondered how all of those fits in together? Okay, so think about it. Okay, if you look at the computer architecture, and I'm going to be very rough, crude architecture, right? So you're going to have something known as a CPU, right? Which is central processing unit. That's essentially the engine of how long it takes it, like how big and powerful it is. When you closely look at that number, it also has something known as what is the L1, L2 cache it has. Okay, so the way it works is the CPU, it operates at very high speed. A lot of times it's like it's tens of gigahertz, which is essentially a billion plus computations per second. Okay. If you're performing that fast computations, you need to make sure you're able to feed the data that fast for it to utilize it. Right? Because remember, in like anything else, you are as fast as your slowest link into the whole communication channel, right? You're trying to do it, any communication, right? If you're trying to like it's going internet and you said, you know what, I have a gigahertz coming into gig channel coming into it because I have fiber coming into it. But if somebody else that you're communicating is using a dial-up, what is the fastest speed you can go? Dial-up. It doesn't matter what speed you have, right? Same thing here. If my CPU is processing millions of transactions per second, I need to be able to feed it, right? What is that? Remember what we talked about? Processor takes an input, right? Where does the input come from? Input comes from some sort of memory. That's where you see it like it's along with the processor, there is an L1, L2 cache, right? Which is nothing but a small set of memory attached on the same hardware as the processor, which is taking the input and providing the input data into the CPU, right? So this is L1 cache. Okay. This is essentially runs into a nanosecond or picosecond, depending on the frequency and the processor speeds, right? Very fast memory. Okay. Typical size is usually it's anywhere between 4 to 8 megabytes only. Okay. If you looked at it, high definition picture, how big it is. Let's say if I want to put it like 24 megapixel camera and take a picture of full resolution, a 1080p picture. It's typically like 15 meg is the file size when I look at the raw file size. This is not big enough to fit one picture. Context, right? But it's very fast. Why? Because it runs on the actual same physical device or a chip in which the CPU is located. Okay. Processing speed is very fast. Okay. Then you get what do we call it? It's a RAM. Right? So when you look at it, say, hey, it's a 32 gig RAM. Right? So anywhere between 16 to 32 gig, or actually 2 to 32 gig RAM, right? So this is 2 to 32 gig RAM. Right? So even on your phone, right? When you look at it, like it's most of the latest Android devices, like so Samsung Galaxy just released S23 last night, this week. Typically it's 4 gig to 8 gig RAM, right? And 128 to 256 gig hard drive, right? Same thing if it's on your computer, when you look into it, it has a RAM, which is essentially nothing but a piece of memory that it's on the same motherboard, right? So now the physical device, like if you've seen at the picture, right? There are multiple chips connecting it on the same physical motherboard. So this is, you have CPU and then you have a RAM, which is on the same motherboard, right? But this one is typically anywhere between 1 to 10 milliseconds, right? Or at the most 100 nanosecond to 1 millisecond. That's the speed. So it's definitely slower, almost 100 times slower than this RAM, right? But I can store more things, right? Then the next one is what we call it is a on-device storage, right? So that's 128 gig or 256 hard disk that we're talking about. It is not residing on the motherboard, but it just essentially resides there, right? So this is a lot of times nowadays it's solid state device. Earlier it used to be a magnetic devices, right? So you can say 70-100 RPM, still get some of that, but most of them is now turned into solid state devices. Okay, so I have a solid state drive. This typically operates into -3 to -4, right? So 100, it will be in a millisecond, not nanosecond anymore. Okay, in this one, I can get it into 1 terabyte to 2 terabyte range. Okay, a lot of storage, but again, 1,000 times slower than the on-board memory. Then it comes, a lot of times it's what's known as a network attached storage. Right? So like you're building a home network, you have your own personal network drive that everybody in the home on every computer connects it and uses it. Right? If you go into the company, right, they have a shared storage, right, which is not connected to your computer, but it's where everybody in the company uses that together. Right? That this is usually into milliseconds, 100 to. So like you can get it like anywhere between 70 to 100 millisecond range. Right? This one is also into hundreds of terabytes. Okay. Then the next one is a lot of times known as optical storage or offline storage. Okay. It's unlimited, right? It depends on how fast you can get the memory from there to that. Now, this is when you look at it, right? Speed-wise, right? Probably a billion times slower, if not million billions, right? Going from there to that. Okay. So the question you always say is, hey, why can't I just put everything here? Right? Why can't I just expand that? Okay. So the thing is, this one roughly cost $100 per gigabyte versus this one cost this. Okay. So for a company, the question is going to be, where would I put my money to be most optimal, right? Definitely, I can't put everything here. There are two reasons, right? One is the cost. Second one is the architecture. I can't have a memory with the thousands of terabytes attached to one computer only. Right? What if that thing dies? Somewhere else I need to store the data. Right? So typically the way the CPU accesses it, CPU never goes to NAS or this to access. Right? Whenever you need an information, you actually, CPU will always connect into this. L1, L2 cache will communicate with RAM to put the data back and forth. This RAM communicates with the storage device back and forth, and vice versa. So every layer has to go to the previous layer in order to get back and forth data. And if I need the data, I need to go to the next layer if it's not in my layer. Right? So there is a constant data swapping happening from one layer to another. That's how the things work in the real world. Okay, part of it's the cost, right? So now think about it. When you're trying to have 1 million customers try to hit on a Black Friday at the same time. That means I have to get all of that 1 million customer into my memory at the same time and process that requirement. Right? So I can't just say, hey, you know what, every time I'm going to go it. If it's going to take me this much time, 1 million customers, it's going to be very slow. Ideally, I would rather have my customer here or here, so I can quickly fulfill their request, right? So that's when this multi-tier architecture came in and said, hey, you know what, we need to solve the problem. How are we going to serve 1 million plus customer at the same time? Okay. So my business layer still remains the same. It says I need to tackle my data layer. So the data layer is now tackled broken down into 2 layers. Okay. One is known as a data access layer. That means I'm going to keep this closed as fast as I can access it. And then I know there are 1 million customers logged in, but you know what? I have 50 million customers. I don't need to bring all 50 million. All I need to do it is, as long as they've came in, this it's active, they're logged into the system. That's the only most likely when they're going to purchase things, right? If they're not logged into the system, nobody's going to purchase it. I don't need to keep them in the memory. I can keep them into my database, which is my lot more longer storage time, access time, but it's in my persistent. As soon as they log in, what if I just bring them here and then address that? Once they are done with making whatever the transaction they're doing it, I'm going to keep it here till somebody else comes in and says, I need to bring that person. So I can swap this person with the person who's going to be active. Right? So that's why they build in a data access layer, which is now then going to interact with the permanent database. So these things will stay in the memory, and this will be delegated to more storage, lower level, cheaper storage. Right? I know I will have a hit the first time. That's why if you notice it, right? The first time you log in, and whether it's your bank account or Amazon account or anything, you will fractionally notice it's going to take a little longer than what you will need at some subsequent request. Okay, it's precisely for this reason. It's trying to bring your profile and information from the persistent storage into the in-memory storage. And that one, you remember, it takes like 100 milliseconds to nanosecond. From there onwards, it's faster because everything is in the memory. Right? This one is going to have limitation, right? It can store only so many customers. So there is going to be a lot of swapping back and forth that are going to happen to figure out which is active customer, which is not active customer that I can swap it. Okay. So that's why you're going to see it like it's the context called a unit of work type of thing, because I need to make sure Here's the other interesting part, right? And specifically in a banking world, right? When I'm transferring money from one account to another account, or from one customer to another customer. Right, it needs to happen all in unison, right? I can't have it, hey, this customer, well, how would you feel it if you say, hey, I need to transfer money from this account to other account? You take the money from one account and you swap out and never get deposited in the other account. How many of you will go and do banking with that bank again? Right, so there needs to be some integrity of the work within your data and the business layers that you need to think through it as you go through it, right? In case of Amazon, right? I bought some item and I requested it to be shipped. I bought an item, but there's no record of shipping. You took my money, but never generated an order to ship the item. Will I go back and buy from that store again? Right? So those kind of things you need to do. Now, another aspect that you need to start thinking about is the presentation layer, right? Remember here? It was very simple. I knew exactly what kind of devices that have it, so I will do that. Here, I don't know what will be the layer. They could be using a small tablet. They could be using a bigger side. And depending on what they're doing it is, I may just going to present the information differently. Right? So if you think about it, right, your email client, just take an example. How your email client shows up in your laptop versus when you're checking the email on your phone. Looks different, right? It is still the same email, still the exact same data, looks different. That's what they started doing, right? It says UI layer is my user interface layer. This is where it's on my phone or in that. Presentation layer talks about what information needs to be presented. My email, list of emails, what I read and not read, type of thing. Okay, so they started breaking that one down into 2 layers. So that's where the 3-tier architecture now started becoming multi-tier, because I have broken down responsibility on the different tiers. Obviously, your complexity increases, right? To manage it, to test it, everything. So as you go through it in a world, the more the complex it gets it, the more things you need to worry about. But there is a reason, right? They're breaking it down to benefit, right? Now, instead of treating only 100 customers at a time, I'm treating 1 million customers at a time. Like my scale is different. I still need to give them the same experience. How many times do you feel it? Like it's whether you're doing it now, Super Bowl will come, right? So NFL streaming will happen. I remember the first time they just launched it. The number of users who try to access that stream was much higher than they could handle it. What happened? Servers crashed. Not everybody gets the same experience. Right? So there's still need to worry about some sort of planning and those things happens, right? But you need to start thinking about what is the limit, right? So you need to start testing it. At what point it's going to fail? And what will be the impact when it fails? Right? As you go through it, you need to think through those things. So it becomes a more complex for you, not only just, so developer is going to go figure it out a way to develop, right? But if you're a quality assurance person, you need to think about how you're going to validate the quality remains the same. And what all tests you're going to run it to validate that no, it doesn't impact. Right? Now you have to think about all those different scenarios as you go through it. And then the proliferation of internet kicked in. Right? This was 90s, the multi-tier architecture. Came in 2000, 2005 time-ish. Internet has been kind of a lot more popular. The e-commerce started going into the effect. That means I can't just offer it myself, right? Earlier it was easier, right? I walk to a store, purchase something, give my credit card or give cash and get that transaction completed. Cash is no longer options, right? That has to be some sort of electronic format, whether it's some sort of a bank account or a credit card, right? But think of it, if I'm a small mom and pop company, am I going to have my own bank processing? No, I'm going to use some sort of gateway because I don't know what all payment all the customers are going to bring in. Some may bring credit cards, some may bring it Visa, some may Master, some may just give me some sort of electronic PayPal type of cash. Right, then I need to start thinking about, oh, by the way, I need to ship the item, whatever they bought it to them. Right? Now, there could be multiple shipments. Right? The UPS, DHL, FedEx. Right? Or plain old postal service. Oh, but if a customer wants to see everything from my side when I shipped it, right? You go to Amazon, you don't care where they shipped it, how they shipped it, right? You want to see it. Where is my order? Is it going to come today or not? Right? That means now I have to start thinking not only about utilizing services that I offer, but integrating the services that the other offers too. That's where the service-oriented architecture came in. Now I need to start pulling in my services and everybody else's services into a single place in order to essentially provide services to my customer or value to my customer. So your presentation here, still the same, right? Customer sees what they see here. I still have to worry about the presentation versus a UI layer, depending on the what form factor and device they're using it. But presentation is essentially, I'm going to present the information to you, and then you're going to interact with it. Underneath that, there needs to be an orchestration layer now, right? So when you go to Amazon to buy something, right? What is your process? I want to look up something. I'm going to finalize, look the detail, finalize it, add to the cart. I'm going to purchase it. I'm going to ship it, and then I'm going to track it. Right? That's my process that I'm going to do it. So there's going to be orchestration layer. Right? Now let's look at it. Hey, I'm looking at the item. I'm searching for an item. Right? When you go into Amazon, now there are multiple, right? Either Amazon provided or the third-party vendor provided. If it's Amazon provided, Amazon says, I'm going to dip into my services. It says what all I have. But if it's third-party provided, I need to go access the services by the third party. Right? So orchestration is still done by Amazon, but the service they use it could be different depending on where you go. Now, if it's Amazon service, they need to say, oh, I have a whole bunch of inventory and product catalog, right? Because all you want to see it is what product I offer. They're going to see the detail around that product to make a determination whether it's a good fit for or not, right? So let's say if I'm looking for a cable, right? Charging cable for the phone. Amazon provides it. So is a whole bunch of other people sell it through Amazon, right? But I'm not going to just buy it. I'm going to look at it. What is the rating on it? How customers feel about after buying it, right? How long the wire is, what's the specification? Is it safe for the data transfer? All those things, I'm going to look into it. And then once it's there, I'm going to decide, oh, I want to buy it. Is it in stock or not? Right? Based on that, my decision may be changed. If it's not in stock, I'm not going to wait it if I need right away. But hey, I'm buying it for future use, but I wanted to make sure it's the right devices. Then I may just say, hey, back order for me if it's not in the stock, right? All of that things is done, right? Because they still have that inventory system. They're not going to change it every day, different inventory systems. They've put so much money in investment. So think about bank, right? When they started offering you over the internet banking, they didn't change any of the system behind the scenes because people still use it. They still go to the cashiers. They still go to ATM to use that. I'm just providing a different interface to them. Right? So they started breaking it down, the systems now or architecture around it into different layer. And some of the layer, depending on where they are, now spanning across corporate boundaries. Think about it. Earlier, it was much more easier, right? If there is a problem within my company, I can run a dedicated network wire from one location to another location and resolve any of the issues. I can't do that with every possible companies in the world. I can't do it with every possible banking network in the world to collect the money. I can't do it with all the shipping things, right? So now I need to worry about bringing all the services together in orchestration layer and present it. So my complexities now span outside the boundaries of my own corporation. That means I need to test also, right? To make sure, does it work across as expected? Is it still performant? And it is still secure, right? How many of you feel comfortable sharing all of your bank detail with Amazon if it's not secure.
No, I'm kidding.
Quiet. And trust me, I work in a bank. There are a lot of things that we need to go through it to make sure none of the data gets compromised. Right? So that becomes your architecture, right? So now complexity is outside your wall, right? You still have to worry about all this complexity inside your wall. Right? Because there's still an orchestration layer, there's still an application layers, everything is within your boundary. But you also now have to worry about others like banks, you have to like its shippers, right? And the third-party vendors that it's providing services. So now I have to worry about all of those things. Okay, this is around 2005 timeframe. Then Mr. Jobs came in and says it's going to change everybody's life, right? Does the phone exist before? Yes. There are things we used to call a brick phones, right? So those of you who have not used it, anything prior to iPhone generation, the smartphones, they used to be this thick. Literally, it was heavy weight. It was literally 5-6 pound phone. You can still do the thing, but it was not intuitive. It was not usable. It was very expensive. With the iPhone and with the Google phones or Androids, things change with all of the touchscreen phones. Right? Phone is no longer used by a phone. It's used as essentially your communication and your single computing device. Still, I see it's 80% of work you do it. You rarely get in the computer. You just do it on the phone and get it done. But that adds a complexity. Right? Think about it. You're sitting on a car, doing something on your phone, going at 70 miles a speed, going through the western or midwestern towns. Across that, are you going to have a dedicated internet connection? Probably not. You're going to lose it from a tower to tower, or at a best scenario, right? You're going to lose from one tower and gain the connectivity at the other tower. Everything has to work seamlessly, right? Because your call is not dropped, your communication is not dropped. Occasionally it drops, but that's when you have to worry about it as a tester. If I'm trying to do a transaction, trying to purchase a shares while driving at that fast speed, I don't want my connection to be lost. That's a millions of dollars, right? If I'm doing a corporate communications and trying to do like buy something for corporate, like if I'm a banker or a trader and trying to do that. And if my stock price changes just by fractions of dollar, and I'm buying 1 million shares, think about how much impact of the money that happens. Right? So now I have to worry about what happens is when I'm connected on versus connected off. Also, when you get reconnected, do you get everything down? Let's say if I'm checking my mail and I got disconnected. Can I still use my mail? Potentially, yes, right? Everything that has been downloaded so far, I can still interact. I can still type it. I can still type all the response. And as soon as I connect it, it sends back the response, right? But does it try to send everything? No, from the time that I was last connected till now, right? What that means now on my mobile, I have to replicate certain things where there is a local storage. It's interacting with everything. And then whenever it becomes an online connectivity, it communicates back to those servers, which is still remaining all those same complex systems. So now I have to worry about testing not only this scenarios, testing, is this getting in sync? Am I getting all of that? Right? So for every application, it becomes now an additional layer of complexity that you need to architect for it. But as a quality assurance, you need to think about it and you need to test it. Hey, I'm going to test this scenario. Does it synchronize properly? Or does it fire up a new order? And now instead of purchasing that stock that I wanted at only 100 items, now it's purchasing 300 items because it connected 3 times during that phase. Right? I have to worry about all of those from quality assurance person. So this is the current architecture. It's kind of evolving it, like it's I would anticipate as I'm seeing some of the newer trend, and probably another 3 years, you will have an additional layer of architecture, which is going to talk more around distributed computing. Because people now interact across multiple devices seamlessly. You need to make sure you can transition their work from one device to another device. Okay, you can see it's some sort of those things already happening in the Apple world today. Right, your phone, your iPad, and your watch and your Mac OS all are integrated. Right? It's going to change it in a corporate world. It's coming. Okay. Any questions around the architectures? Do you understand the complexity? What's involved? What you need to think about as you become a quality assurance person, depending on the architecture they use it, how the complexity increases. Okay, and there is a benefit. Well, there's always a benefit. That's why they increase the complexity. All right. Let's take a quick 10-minute break. Let's stretch out like till 11 o'clock. Any question online before we break it? All right, let's take 10-minute break. We'll get started with how the software is developed. Now that we know what is the software, how the different architectural world can exist, we'll go about how things can be developed. Okay, let's pause for 10 minutes. So while we are waiting for others to join, any questions on what we talked so far? So you have a folder in front of you. That's your folder, so you can make whatever notes you feel it needed as you go through it. It's your to carry it throughout the course. Any question online before we get started? It's been quite crew on online.
Hi, the link that we got, does that have the folder material?
Yes.
It should have it.
Click on the
Oh,
link.
okay.
I put it out of the chat, so.
Okay.
Yes,
So-
module.
So all the deck that we are talking through it, it's in the module. So as you go through it, like it's all the 14 modules that we're going to talk throughout. What we have been talking so far is module 1. We'll probably just start with module 2 today. And then we'll go with module 3 and 4 and 5 next weekend. Then all the project documents, you're going to see it is in here under the project documents. And then we'll talk about it before we end the day today. What do you need to do with that? There are some exercise activities. So some of the homework as well as activities we're going to give it through it will be in the exercise folder. And then certain software that we want you to download it will be in there. We'll tell you as we come closer to it, because a lot of those software has a 30-day kind of evaluation license limit. So that's why we don't want you to go ahead and download and install all of them, because then you're going to run it out before we're going to start on those modules. So hold on till you get the instructions of what to do about those things. Okay. So you should have, if you're not able to access it, just ping Herschel back. He's here on the chat and then he can resolve some of those things. Okay. All right, good, let's get started. So we talked about all of the software architecture, right? Now let's give an example, right? Similar to building a house, right? If you have the same blueprint, and you go to 4 different contractors, do you feel that they will build exactly the same way?
No.
Do you feel that they will build the same thing? No. Most likely, right? They will build the same thing. but they will not follow the same process, right? So the same way within the software world, right? People will do it a little bit differently, still accomplish the same objectives, right? But when you abstract it and think about the life cycle, right, it will still be the same, right? So let's walk through a life cycle. Let's say if I want to build a house, what is the life cycle I will go through it, right? And then we can think about software later once we have a good understanding of house, right? So let's say when I want to build a house, what is the first thing I'll do? I'll first make a determination. Do I really need a house or can I rent it? Right? That's the first thing I'll do. I will also identify, do I really need to settle down? What are the other characteristics I need to do it, right? So there is some planning will go in before even I make a determination that yes, I do want to build a house, right? So there will be some factors that I will be evaluating it before making that decision, right? That's typically called planning, right? Hey, I'm thinking around buying a house. Let me go make a determination whether it really makes sense for me or not, right? Once I decide I do want to build a house, what is the first thing I will start doing? Even before designing,
Finance, and then this is how much.
analysis, right? So I'll start, what kind of analysis I'll do? Whether I want,
What kind of.
whether multi-story, single story, right? Where did I want it, right? I want it in the suburbs, or do I want it like it's in the downtown? Do I need it in a rural area, right? How big house I want it, right? I'll start defining some of those factors as what all I wanted first. What are my requirements now? Versus what else I can do down the road, right? What is the current block, right? And then you will start also thinking about finance, right? Is okay, once I understand what kind of house, I'm gonna go trying to like it's do as well. What it's gonna cost me. And based on that, I'm still gonna keep changing back and forth till I come up to an agreement where I think, okay, now I'll build this kind of house and this is the kind of money I'll be able to spend it. Right? That interface is analysis, right? Now, once I decided that, hey, I wanted to build a house, let's say in the suburb, and I want a multi-story house, and I want a standalone house type of unit, then I will just go ahead and like it's get blueprint, right? I'll get contractor and says, let's look at the model, let's look at things, let's look at what the architecture is going to look like, right? So I'm going to migrate from an analysis phase to design phase, right? What exactly I'm going to build it, how it's going to look like, right? What will be the blueprint, what will be the things in those. Once I go through those design, I will probably go through some sort of approval in the local county and everything, this can I do with this kind of things. And then I'm going to get into construction phase, right? I'm going to get the contractors who will just say, hey, here's my blueprint, or ideally I'll have the same contractor who goes through the blueprint to the construction phase. We'll just say, this is what I want, here's how I want it, you get the blueprint, you build it, construct it, right? As they construct it, right? I may make some minor adjustments here or there, right? Because it's going to take a long time to build it, right? Then I'm going to get into testing phase, right? I just don't want them to build a house. I want the actual county to come in, inspect it, and make sure everything is building it according to what it needed. And before even like it's going to kind of move in, right? I'm going to go do a walkthrough, right? Is everything working as expected before I write that big fat check to the contract? That's my implementation and testing phase, right? I'm testing the house as I go through it. Then the next phase is going to be, am I satisfied with the house or not, right? So there's going to be some sort of acceptance. Like everything is working as expected. Everything is what I wanted it. And in the price range, in the shape and the state that I wanted it. If it is, then I'll write check, right? I'll accept and says, okay, I'm going to move into the house. Good. Once you move in the house, what is the next phase? Maintenance, right? Your upkeep of the house and everything. Occasionally it says, okay, now I'm going to build, maybe I want to furnish the basement, or I want to build a patio, or I want to build a deck. Right? Those are additional projects, then I'll take it. those projects will go through the same cycle. Right? Planning, analysis, design, construction, testing, acceptance. Right? And then it get into the maintenance. Right? So my house's life cycle is going to be the same. Okay. Think about software life cycle. Okay. It's the same way. Right? I'll start with the planning. Do I really want to build a house? Do I want to really build this software? Does it make sense? Right. Think about it. All the companies go through the similar phase, right? Then their first reaction is not to automate everything. Right? First reaction is, let's just set up the business. Right? And as the business evolves, you're going to start thinking about, hey, what are things I can do it now to essentially make it more efficient, make it more productive, make it less costly, more profitable, right? Based on those things, you're going to start making a determination. Do I really need a software? Right? So initially, like it's, hey, if I'm a small company, right, I'm doing all accounting myself. I don't need an accounting software. Right? But as the company grows, as the more activity comes in, more purchases comes in, more bills comes in, more payments needs to go out, right? It's probably easier if I have some sort of accounting software so that I can easily track things, right? So those kind of things is going to make it in a plan. Then I'm going to make it an analysis. If I decide that, yeah, I need some sort of automation, I need some sort of software, then the question is going to come in is, what kind of software I need? What should be the capabilities? Is it when I say, is it a bicycle that I need to go from one point to another point? Or do I need a really big truck that I need to hold with? Similar way, I'm trying to do an accounting. Do I need an off-the-shelf accounting software or do you need to build one dedicated? That is mine. Right? If I'm a big company, anything from the off-the-shelf is most likely not going to work. I need to buy probably a software, customize it, configure it to meet my needs and my processes. Right? So that's the analysis phase. Then you're going to get into it. Now that I know what I need to build, what capabilities it needs to provide, how I'm going to design it, how it's going to fit into my business, how it's going to fit with the other systems I have it, how it's going to interact it. Right? Because it has to be seamless, right? You can't have it, hey, I'm doing one way for this activity, I'm going to go do another way for this activity. It's not going to be efficient. Then I go from a design to an implementation. Once I design it, let's go ahead and build that software. Let's build those capabilities. And as you build those capabilities, you're going to test them. Once I test them, at some point I'm going to say, yeah, it needs it, whatever I want to do it. They're going to go ahead and accept it. At that point, it becomes a maintenance. Right? And then if I want to add additional software or additional feature or capabilities in that, I would still go through the same cycle. Okay. Exactly similar, right? Similar to what I would do it in a house. Right? It's essentially need it, analyze it, design it, build it, test it, deploy it. That's the life cycle for software. Any questions? Okay. Now comes the part as I was talking about, right? If I have a blueprint and I want to build a house and I give it to 4 different contractors, they're going to go through the same cycle, but the way they're going to build it, it's going to be a little bit different. Same with the software. Every time, no matter what software I build it, it's going to go through this development life cycle. But how everybody builds it, goes it from analysis to test phase, that transition is going to be different. Right? And that's what the software development methodology comes into it. There are 3 prominent methodologies that you can see. Okay. The first one is Watherfall. Okay, that means we'll talk about it. I need to know everything before I go to the next step. That's a waterfall. The second one is known as a rational unified process. I'm still going to follow it, but there are some iteration in it so that I learn it from as I build it. I can start essentially building it towards a big picture. And the third methodology is an agile methodology, which is essentially now it's getting it more popular because of the way the consumer mindset has been shifted. And I'll talk in a moment when we go through it. Okay, so those are the three methodologies. So before we go into methodologies, let's think about for a moment, and I'll give a banking example. Okay. Go back 25 years ago. How was the banking was done? Right? The big banks will come up with, here is the type of services I'm going to offer to my customers. They'll go take it 2-3 years to build those services. And then they'll just give it to the consumer. And consumer will have no choice but pick and choose from whatever is available. Whatever you as a company are providing it, I'll take it. Right? In that model, all of the way you wanted to do banking was defined by the companies, defined at the corporates. That this is the way you're going to do it, right? This is the way you're going to give all the payments, right? You will write either the cashier's checks, or you will do a fat transactions, wireless transactions, or wire transactions, right? And banks will charge you hefty fees, right? If you want to give money to somebody else, you will write the checks. And that's the only way you will do all the banking. Okay, flip over to the last 25 years in today's world, right? And some of you might have done it. Some of you have kids, like my kids, who goes through on the banking, which never ever want to go into the branch, right? When you talk about the millennials, ask them how many of them actually went into the bank and see what the branches looks like. They don't want to go. They want to do everything on mobile. They don't want to write the check. They don't want to carry anything, right? They want to electronically transfer all the money, but they don't want it to be charged for those transfers, right? So the banks are kind of shifted. The world is shifted into, I don't define what you want. You tell me what you want, and either I provide or I don't provide. Right? And the consequences, if I don't provide it, what's going to happen? You're just going to go to somebody else who's doing it. Right? So you think about it, the banking relations people with my generation and my parents' generation have. They rarely change the banks. They rarely change the affiliations. Flip it to today's generation. If you don't provide a service to me, somebody else is provided. Thank you. I'm going to go take my business then. Okay. Now, what did I say about that? So you need to think about it from a company point of view. In the olden days, you could afford it to spend 2 years, 3 years to come up with a product, build a product, and roll it out. And today, if you haven't come up with a product in a quick, timely manner, guess what's going to happen to your customer base? They're going to leave. They're going to go to somebody else who is willing to provide it quickly. Right? That's what it is, kind of evolution of the software development methodology also. Okay. And the most important behavior you see it is in the agile development. Okay. So let's take an example. Okay. Uncle Sam is coming in with the tax software. Right? So let's say if I want to build a company, build a software which does it all of the taxing. Okay. Now, do you know how often the tax laws changes? Every year. Congress comes up with 5,000 pages of tax laws changes every year. Okay. And then there are some which automatically time bound, things changes it, rules changes it. Okay. So if I have to build a software, right, there are two choices I have. Either I build everything in one go, figure it out whether it's going to stick with customers or not, and then put it to the market, right? The downside is till actually that software is sold to the customer, I don't make a money. That means I need to make a huge. Typically, runway is like anywhere between 2 to 3 years to build and integrate all of the changes that government puts it out fresh every year. Okay, what does that mean? So if I want to do that, I need at least first 3 years to build out a base, for which I need to continuously pour in money to come to the market, and I don't even know if the customers will like it or my software. Right, so I won't know it till end of 3 years. Right? Is that good financial sustainable model? It's not, right? So I need to start coming up with an innovative way of how I deal with that. So one way I can do it is I know I want to build a tech software that gives it everybody ability to do that. But I don't have to take it everything, right? I can start simple and say, you know what? There are a lot of variation and permutations of how the people file tax returns. I'm not going to worry about everything. All I'm going to worry about it is simple 1040 easy. And I did market analysis. It's X% of the people, all they do it is file 1040 easy. They don't need anything else. What if I just build only that piece of software and sell it to that only 5% of the people who uses that? So my market is reduced from 100% of people to 5%. But what I can do it quickly because I don't have to worry about all the other permutation, combination, complexities to build it. All I need to do is one simple text table, get the information, right? And based on that, I apply the text table and come up with the text. Simple enough. I can build something within 2 to 3 weeks time frame. I can deploy it, and I can start selling it. I can start having those customers paying it. Right? So now I'm not doing a huge investment. I'm doing a small investment. I'm started making money. But at the same time, I get validation from those customers. If they don't like it, and I decide I need to can it and go with some other business, guess what? How much investment I lost? Probably only 1 month worth of work, or maybe a little bit more based on that. But not a huge that like it's 3 years. I sank in multi-millions of dollars before finding it out it's not going to work. Right? Alternatively, like it's if I say it's yes, it's taking, I got the feedback. Guess what? Now I make it instead of 1040 easy, I'll just get it 1040 standard, no itemized, nothing that standard 1040 deductions. So now I expanded my user base to a little bit more, and I can build on top of my whatever software I build it, I can add a complexity on it and start selling it. Then I can add it as, you know what? Now I'm going to add a state. There are 50 states. I'm not going to go and try to sell every state. I'll do one state at a time. Right? So I can incrementally build my software as I go through it. At every phase, I'm actually releasing the software. People can use it, purchase it, pay it, and get the benefit of it. Right? So that's an agile way of doing it. It's a mindset. Right? I have a vision. Right? Within that vision, I'll say, okay, what is my first cut? I'm going to look at it. Within that, I'm going to go through my entire life cycle. I'm going to understand what the requirement is. I'm going to design it. I'm going to implement it. Right? I'm going to test it. I'm going to deploy it. Right? The whole life cycle. People are going to start using it. They're going to start paying it because I'm already selling it. Then I go take it the second iteration. It says what I'm going to do in the second iteration. Then the third iteration. So I incrementally build all that software. Right? And I'm testing as I go through it. So every time I add an additional increment, I'll have to make sure, did I break anything here? No. Does the new thing I added works? Good. I'm good. All right. That's an agile mindset. Everybody with me? Makes sense?
So what happens if it doesn't pass the test on the second one?
Then that means you have to fix something. Whatever didn't work you need to fix it. Yeah, you can potentially, think about it anyway, right? You're building a Lego, right? You're building a small structure. If it doesn't pass, it fails. What do? You rebuild it, test it before adding another one, right? Same philosophy. Think about your Lego building one. You're building it as you go through it and making sure the structure works as you go through it. Right? Still doing all of the activities in the software development lifecycle at every iteration. Okay. So this is what it is, kind of an agile methodology, right? It's A lot of people think about this is like 2 to 4 week increments. Right? Your first increment may take more time, like it's anywhere between 3 to 4 months, depending on what is the first slice you want to take it. But every incremental value, then you add it, you start focusing on 2 to 4 week increments. Okay. The goal is to continuously evolve your product. Because your customer is going to tell it what they wanted, what they like, what they didn't like it. You take the feedback and you build it incrementally. Okay, so that's one agile methodology. And as we go through it, we'll talk in a lot more detail a little bit later what it means and what ceremony, how the work gets done within each one of them as we go through it. Okay. Any questions on this before I shift into the second one? All right. So the second one is called a RUP, or what's known as a rational unified process. This originated from the combination of work that IBM was doing with some of their clients. Okay. And if you look at it, right, the entire effort in this scenario, it's broken down into 4 phases, known as inception phase, elaboration, construction, and the transition phase. So this is typically used not for a small project, it's used for a large project. Okay, let's take an example. As I mentioned, I'm kind of like it's a lot more connected to the science part, right? So NASA is trying to like it's go back to the moon and Mars, right? It's a huge project. If you think about it, there's a lot of work needs to be done. Can I say that I'm done till actually I put the human into Mars and come back? No, that's my project, right? But can I test things incrementally as I go through? Right, what they've done is they've said, okay, we're gonna first figure it out. The rocket, can the rocket make it outside Earth's atmosphere? Right, then they said, okay, if it makes outside Earth's atmosphere, can I take it to the moon and be back? Right, that's what they just did it, right? And back in November, they launched a new generation of rocket, got to the moon and come back. The next phase is, okay, fine, we can go to the moon. Can people survive in going to the moon and come back? So that's what they're going to do it this year and next year. It's going to put a people to go to the back. Then they're going to do it as, can I go it beyond the moon? Because that's a long journey going to Mars and coming back, right? Once you go to the Mars, can I lift it back from the Marses, bring people back? And they don't have the infrastructure like here, where you have a whole bunch of people building things for them when they go to the moon or Mars, right? They just have to deal with whatever they can build it there and do that, right? It's a huge project. You need to think about it in different phases. So what they do it is they come up with an idea, inception phase. They're going to do a whole bunch of business modeling and says, does it even make sense? Can you even make it happen? Right? Then they're going to get into the elaboration phase and says, okay, what all I needed to go to that? Can I start developing those systems? Can I build those pieces? Right? That's analysis and design phase. That's what they are currently doing. Once they build it, they're going to say, okay, can I construct that? As they build that, construct that, you're going to do that. And then they're going to operationalize it finally. They're still going to do all those things, business modeling, requirement, implementation, testing, and the deployment finally is when the final effort gets launched out. Right? And when you think about it from a software point of view, there are a lot of pieces that it can connect, right? So if I'm sending somebody to Mars, right, I not only have to worry about the propulsion and navigation systems, I have to think about the human survival systems, right? Like oxygen, food, sleep cycle, gravity, shielding it from all the different solar waves that comes it along the way, surviving that long and loneliness. Once you reach there, right, the habitat system in wherever they land, right? All of those systems has a software component that needs to be connected with the health system, so to see if the astronauts are survive or not. If they get sick, how I'm going to deal with those, right? So there's going to be a whole bunch of software they're going to build it. But I'm not going to finish the project till actually done. Am I releasing anything to them? No, I'm not, right? The only way I know it, everything works is when the final deployment and the testing happens. Understand how big the project is, how we can break it down into different things. I'm testing it, different pieces, going through it. Right? It's a big analogy, right? But think about the software also in similar ways. Right? Whenever I need to build a large system that involves multiple things, right? The difference between the Agile way versus this one is in Agile way, actually, I'm delivering and deploying something every sprint for every iteration. Here, I'm testing it out, validating the hypothesis and building on it, but nothing is released at actual to meet my goal till the end. That's the only difference, right? I'm still building incrementally. But the value aspect did not get delivered till I actually did it. Understand the two key differences? Right? If I'm building the tech software, to take the same analogy here, right? I'm still building it, I'm testing it, but I'm not actually selling that software till the final deployment is done, till the final software is created. Good? All right. The next methodology is the waterfall methodology. Okay. In this one, they go by whatever your software development lifecycle is and say, I'm not going to move to the next lifecycle phase till actually I know everything in the current lifecycle phase. Okay. So first phase is requirement analysis. That means till I know every text law that I need to code it, all the different combination and permutation of different text forms and all the schedules. As long as I know that, then only I'm going to go into design phase. If I don't know any one of them, I'm going to wait till all of that thing is flushed out and detailed out. Okay. Once all of that is detailed out, I'm going to build my design to build everything. Not just one thing, not just two things, all of the pieces. I'm going to build all the state. I'm going to build all of the different types of variation, whether it's 1040 easy, 1040 or itemized or schedule deduction, all of those things. Once I'm done with all those designs, then I'm going to code it. Well, if I'm doing the code, if I figure it out, hey, I missed this component, I need to know more. That means I need to flush out more requirements. I'm going to go back up here. Check my design again to make sure it's still going to work. And then I'm going to come back to code. Okay. Once I code it, then I'm going to bring all the pieces together. I'm going to test all of them together. And then I'm going to deploy. Okay. In this case, it's a big bang approach. You're not going to see any tech software from me till I'm actually ready to release everything. It may take 3 years, it may take 5 years, but that's how long it's going to take it. And anytime anything changes in between the way, I'm going to reset it and going back. Think about a waterfall, right? The way waterfall said, it's if you take water to a higher stage, it must flow through the same way. It cannot skip anything, right? That's what this is about. If I kind of reset anytime, I have to follow back the same path. It cannot skip any state. That's the waterfall. That's how typically most of the software was built. If you go back to the example that I was talking 25 years ago, the banks will define the product for you and then give you a product because they were doing all waterfall. I'm not going to release the product till everything is defined and it's ready to launch for a customer. Okay, because they could dictate, right? The customers were not defining what product they needed. The banks are defining, we are going to offer you this product, and that's what you're going to use it. Right. In today's world, customers are telling what they want. You can't wait it 5 years. It says, if you don't have it that next month, sorry. I'm going to go, somebody else will offer it the same. Right? That's how banks got caught off guard, not having it all the electronic payment system. That's why if you go to the college, what does kids use? Venmo. They don't use anything else. That's the example. Okay, any questions around three methodologies and how it's different from each other? Most of the companies are shifting to this because that's what the reality they have to deal with. Okay. There are still a few companies who try to do somewhat rough, somewhat waterfall, because they're still learning the way to do it. Because Agile is not an easy thing to do. Think of this way, right? If I'm building a house, I don't know how many bedrooms I will need it, how many floors I will need it. Is it easy to build it? You're not going to demolish house after every iteration to build a different foundation. Right? This is not an easy thing to do it, but that's where your customers are telling you that if you don't go this way, you won't survive. Think of Yahoo, think of Kodak, right? Once very reputable companies don't exist anymore. Think of AOL Time Warner, or AOL, not even Time Warner. Time Warner was later. But they exist, they don't. Right? This is where most of the company is shifting because the customer is driving their demand. It's not because this is the cool thing to do it. This is hard thing to do it. Right? Because you have to know, you have to evolve it. You have to understand how everything's going to fit. Just like you say, what if the second iteration, the first iteration doesn't work? What also means that is you can do certain testing, whatever the new features you added it easily. But if you have to test the whole thing, the whole harness, that means you need to start thinking automation. Right? That's what you say. It's, the first step is always manual testing. Unless I know what needs to be tested, can I automate? I can. Right? So the first step is always a manual testing. But at some point, you need to start thinking about how you're going to automate that so that I can make it quicker and quicker to do that. Let's say if it takes you to build the testing every iterations about a week and gets an execution about a week. At some point in third or fourth iteration, if you're doing everything manually, you're going to come to a halt because now you need more testing time than actually you needed time to build the software. Right? That's where things comes in. That's where like we'll talk about the different types of testing, like regression testing, automation testing. Those things you need to progressive shift towards that as you build it. You'll still need to do manual testing for all the new functionality that you build it. But all of the existing functionality, you need to learn how to automate that. Okay. So where does software quality fits in here? Okay. So let's think about like it's building a house, right? If you wait till the end, after the whole house is built, and you find it out they did not route the plumbing and the electrical system properly, is that going to work? No, right? Because what's the cost? They have to rip everything, right? Because everything is behind the drywall. Now you need to reroute it, you need to do it. The cost is significant. Versus would it be easier as they're going through it, you're going to have an inspector coming in as soon as you build the frame and says, is frame working properly? Then they do an electrical system, is that working properly? Before they put the drywall, they put the plumbing system and says, is that working properly? Right? You do an incremental quality check as they go along the way and do certain testing along the way. It'll become a much more easier, right? The troubleshooting and any issues comes up at a later stage, it's going to be minimized. Right? Same thing with the software world. The sooner you identify the issue or validate that things is working as expected, the better off you are, right? That's why like a lot of people talk about, hey, it's a testing profession. And I'm saying testing profession is just a small piece of it. Your quality assurance, you get engaged it from early in the software development lifecycle to understand what they're building, why they're building it, how they're building it, and it's how it's going to validate what's going to work and what's not going to work. Okay, that's why quality needs to be built as part of your software. Can be afterthought. Because guess what? When you test it and identify a problem, the problem is already in the software. Right? So at that point, all you're doing is detecting and mitigating it. You're not preventing it. Versus if you are involved earlier, you're preventing it from happening. So that's why it's key for software quality assurance mindset. As you go through it, that's why I went through architecture in SDLC. We didn't start from testing, we start from what you needed. Okay. So now let's talk about it. A little bit about building the software. Okay. So now that you have a frame of the overall software development process, let's talk about how you progress through each one of the software development lifecycle. Okay. So the first phase is what in the software development lifecycle? Planning, right? The planning is typically just says, do I have a problem? And do I need to do anything about it? Right? That's what it's planning about. Right? When I wanted to build a house, right? The first thing is, do I need to build a house? And is there a justification to build a house? Right? Those are the two things. That's the business problem that I was trying to handle. Same thing, whenever you're trying to do it in any software development, the first thing it's always going to ask it is, what is the business problem that you're trying to address it? And what is the value? Why are you even trying to address it? Okay. So let's take a simple example and we'll go through it. Everybody's familiar with Amazon, right? How they do it. Let's take a moment. Let's just say it. I'm a small bookstore company. In a city, I have 3 locations and I have a warehouse. That's it. That's my presence. Okay. And there are a whole bunch of things that I have. Okay. And all I want to do it is run an efficient business. Right. So when you look at the efficient business, there are multiple things. Let's take an example. Okay. I want a customer to come to a store and then ask what they want. Right? It's a book. Right? I'm selling only books, so it's a bookstore. So whenever a customer comes to me, they're potentially coming for a book for them. Right? So let's take a scenario. I get a pile of books and I pile it everywhere in the store. And a customer comes and asks me, says, hey, do you have so-and-so book I want to purchase? What is the normal reaction I'm going to have? I have to go through all the books. That's not, I don't have any system. Let's for a moment think about all the systems out. Think purely from a business point of view. What is the first thing I'm going to do? I'm going to go through all the books. And then most likely, I won't know the answer till I go through the last book, whether I have this book or not. Right? Let's take for the example, it takes me 8 hours to go through all the books that I have it in my store. And if a customer comes to me, says, do I have a book? I'm going to spend 8 hours looking through it to just give an answer whether I have that book or not. Now, let's make it inside. I said, you know what? I don't have it, but I have 2 other stores. Can you go check there? So the customer goes there, repeats the same process, with the 3rd store, and do the same thing with the warehouse, right? So just to answer simple customer questions, did you have this book or not? It took me 32 hours as a business. Everybody with me understands why it took 32 hours? Right? So that's the problem. I'm not efficient. It takes me 32 hours to figure it out. I need to do something about it, right? So there are multiple things I can do, right? The first thing I can do it is, you know what? The search process, it takes a lot of things. What if I make an improvement on it? What if in every book store, I kind of organize everything in alphabetical order? Right? Simple, easy thing to do, right? I can organize all of them as they come in, organize it. So when a customer comes in and asks me that question, I don't have to go through everything. I can quickly scan through it where it is, that alphabet or whatever they're looking at it. And I could order by author, I could order by title, whatever they order, I can do it. Right, I can find it. Right. Let's say the customer wanted by title. Customer knows the title and author and now organize everything by title. It's an easy for me to find it, right? It's not going to take 8 hours. Let's say it takes only 1 hour now. So now, instead of 32 hours, the same process, if I have to repeat now, I can get done in 4 hours. Right? So what did I do? I did a process improvement. My whole desire was to not spend 32 hours behind that process. And I reduced that from 32 hours to 4 hours. That my driver was process improvement. How can I make my search process efficient? That's one problem. What if instead of that, I said, I wanted to be a productivity. Okay, so I flip it and says, you know what? Every time a customer asks a question, in the first case, it was taking one employee 8 hours to serve one customer. Right? And I needed four employees to serve one customer if it goes across that. Right? Now, if I have 100 customers, am I going to have 400 employees? Can't. Instead of serving only one customer a day, what if I want that employee to serve 5 customers a day or 2 customers a day? Right? That means I'm going to increase the productivity from serving 1 customer to 2 customers. What can I do? I can do the exact same thing. I can organize everything into alphabetical order. Now the same customer is kind of addressed by an employee, but they can address 8 customers in a day instead of 1 customer a day. Right? So I increased my productivity of my employee. But my goal was I wanted them to serve more customers versus I wanted it to be quicker process. Right? Same problem, but depending on my primary driver, it could be this or it could be this. Now let's talk about the cycle time improvement. Okay. How long it takes it to actually serve the customers? 32 hours, right? It says, so from the time that customer comes in, and then they potentially buy the book from me, it could take up to 32 hours. What if I want to reduce that cycle time? Because the sooner they will purchase it, the sooner I'll make a profit, the sooner it will help my financial flow of the business, right? So what if I kind of say instead of 32 hours, I want to reduce that cycle time to be 5 hours? Right? So end-to-end serving customer now from 32 hours to 5 hours. Because of that, I would want to do alphabetical order. So they can get it done in the first store, or they can do it. Oh, by the way, one thing I can do it is when customer comes in, I can just like call the other store also and says, hey, do you have this book? Can you find it out? Right? So instead of doing sequential 5 hours or 4 hours across 4 stores, I can reduce that even further to 1 hour, right? Because that's what maximum takes it in per store. Now, did it help with productivity? Probably not, but did it help with me cycle time? Yes, right? So if I take that approach, then cycle time improves it, right? In a software world, right? I could just say, hey, I'm going to search on system that is connected to all 4 stores inventory. Right, my cycle time is significantly reduced. Right. Did you see it? How solution and benefits can be depending on what things I want to drive? Then let's talk about reducing the cost. Okay. So think about one employee and paying, let's say, to keep it math simple, $10 an hour. Right? It takes them 8 hours to search for a book. So it took an $80 for them to serve 1 customer. Across 4 locations, it could take up to $320 to serve 1 customer and answer 1 query. Can't afford that significant cost. Right? What I want to reduce that cost of amount of the time that it takes and money that it takes to serve 1 customer. I want to reduce from $320 to $10. What can I do? right? If my motivation is that, then I'm behind reducing cost. Now that may require, let's index it. Let's set up the parallel search so that all 4 steps can be looked into it. Let's automate that search. So then it's now even easier, right? So I did a whole bunch of solutions, but my goal was to reduce the cost. As a benefit, it helped with the productivity, it helped with the process, all of that. But my goal was reducing the cost. Good so far? Same business problem. Depending on what is my primary driver, I'm going to tackle it differently, right? The last one. Let's say, so far I've kind of limited people to walk into my door to order the book. What if I change that and says you can order the book over the phone also? Now my customer base from the local town where I have all this stores is no longer restricted to only people in the local town can buy books from me. As long as they can phone me, they are part of my customer base that they can order a book from me, right? So I went from a market share of just only 100,000 people as my potential market to now the whole nation. Let's say we'll just do a limit to 48 states where I will ship it, right? But now I became, instead of just one small town, the whole US population is what I increased it, right? I wanted to improve market shares. I want to sell more books, right? And the only way I'm going to sell more books is if I expand my market. Right? So depending on what problem I'm trying to solve it, it's going to fall into one of the 5 categories. Okay. Everybody good with me so far? This is all in the planning phase. Okay. So this is what we're going to do. We're going to do some exercise. Okay. So let's see. All right. So in front of you, you have a folder. If I may borrow one of your folder. Okay. It has multiple tabs. The first tabs is all of the PowerPoint slides that we're going to share with them. Okay, but if you go beyond that, after the first tab, there is another tab which talks about exercise. So for those who are online, hold on for a moment, I'll tell you where to find it. Okay, but you have all of the exercise tab. So that's how your folder is organized. Okay, the next tab is the project documents. Okay, and we'll talk about before we close the end of the day today what to do with that tab. But that's the project document. Then you still have another tab with the project document, and then there is a final tab with some additional material. Okay, so far you've been pretty much on the first tab. So flip it to the end of first tab, where you have all the exercise. Did I mess it up? Yeah. So flip to that tab. You have exercise. What you're seeing on the screen is the same thing, exercise 1. What I want you to do in a moment is to read that and then help me answer one simple question. Okay. So hang on to a minute. Let me talk to the people who are online. So those who are online, I'm going to follow the chat. Okay. Then there is an exercise folder. What I want you to do is go into that folder, and then there is all project files. So open that all project files, and the first thing is exercise 1. Okay. So I want you to read the exercise 1, which is same as this thing. What you're seeing it in the share. I'm going to give you 5 minutes to read it, but I want you to answer only one question. There is a business problem that's identified in there. What I want you to do is read it and tell me if you have to categorize that business problem into one of these categories, what category you will tag that to. Now, again, remember, as I say, there may be multiple solutions or multiple things that you can accomplish, but there's only one primary driver why we'll do it. So all you have to do is identify what is the primary driver, right? Is that business problem telling you to improve a process? Is it telling that it needs a productivity improvement? That's why they're trying to address that. Is it a cycle time? Is it a cost reduction or it's a market shift? Which one of the 5 things that it is trying to address? Okay, that's what you need to look into it. So I'm going to give you everybody 5 minutes to read it yourself. Think about it, which one of that, and then we'll start having a conversation of which one we are doing. Everybody good online?
Yes.
Okay, so it's 12:03. I'm going to give you a time. Let's give it 10 minutes, 12:10. I want you guys to read it, identify what the problem is, and at 12:10, we'll start talking about it. Okay. For my benefit, I'm gonna put it here. Some question? Okay. Does anybody need another minute or you good? All right. This is what we're gonna do it, right? So it's doing the math, right? We have total of 16 people, 6 online and 10 here. Okay. So as we go through it, I've kind of put the 5 things. What I'm expecting is everybody to vote and give their share of they think this or versus that, right? So I'm kind of being a teacher. We're trying to like it say it's can I add this up to 16? Right? So what I wanted is based on your reading of the problem, and then I'm going to actually turn on this also. So if you can just tell me through the voice, let's start with the first one, which is essentially, how many of you think the problem is for the cost improvement? How many of you think it's a process improvement? Raise your hand in the classroom first. 1, 2, 3, 4, 5. Okay, how many of you online think it is a cost? So Rohini, so 5 and 6.
Anjali,
Chris, 8.
Anjali,
All right, Anjali, I got you. So 1, 2, 3. So 8 of you think it is a process improvement. How many of you think it is a productivity improvement? Oh, Trevor also updated it. Yeah. So it's 9. Okay. Productivity improvement, lower your hand. How many of you think is productivity improvement in the class? 1. Okay. Chris, is it for productivity or process improvement?
Process.
Okay, so you can lower your hand.
I don't know how to do that.
Just same way you like it, raise hand, you should be able to click it, it's lower the hand.
Okay.
So it's only 1 of you think it's a productivity improvement. Okay. How many of you think it is a cycle time improvement? No. If you already raise your hand, you cannot raise twice. What is the primary driver? That's all I think. And again, I'm still good at math. I can still count to 16. So that's what I'm going to do. So 5 in classroom. And then Navina, you say it for the cycle time improvement?
Yes.
6. All right.
Jayashree, I also say that cycle time improvement.
So you say cycle time. So 7. So obviously my math went wrong somewhere right here. There are 16 people in the class, can't have 17 hands. So whoever raised hand twice, let's talk through it. What do you think is primary? You're going to make me redo my math again. All right, let's start with the process improvement. Okay. How many of you think it is process improvement? Let's just say it. So let's redo it. Now this time, raise it only once and be sure which one it is if you're raising it. So 1, 2, 3, 4, 5. And then Trevor is for the process, so 6. Chris is for process, 7. Rohini, you're for process?
Yes.
8. All right, so we have 8 people for the process improvement. All right, lower your hand for the process improvement. Let's talk at who else is for productivity improvement. Raise your hand for productivity improvement. Anybody online for productivity? All right, so that becomes a 0. Cycle time improvement. So we have 5 in here and Navina is 6. Anybody else for the cycle time? Jayashree for cycle time, so 7. All right. Okay. Where is last one left? Tell me whether you're for reducing cost or improving market share. Somebody's left. This is what I have with you teenagers, and I've got it very good at it. So somebody is shy or not sure. What is it? Not sure or shy? Holding up the class. No pressure. Something is in your mind. You have to speak it up, or you turn it on, you walk away from the desk, which is most likely the case looks like.
Okay, we can put a question mark.
All right. Okay. So for those process improvement champions here, I'm going to go back. Tell me why you think it's a process improvement. Tell me what in the document or in the paragraph indicated to you that it is a process improvement.
I think the second paragraph which says they have the dealer who help them to manage all that problems. I feel that it might
So-
possible that sometimes the process that person can not be able to manage correctly or take more time, or it's a single processor that can.
So tell me what exactly the wording, and I'll highlight that here in the process improvement.
that the agent will be responsible for signing up the data's dealer shop that do repairs.
That's what the process that you think it is? This one?
Yes, the whole second paragraph. Yes, that's.
So that drives you to think it's a process improvement. What is the process then? Which process they're trying to improve? Sandy?
So dealer reaches out to the lender via email. For me, so there should be another kind of process, through the email, he's going to check it, it's going to take a long time, maybe.
So but what is the overall process to get the loan? Is that the process that you're trying to improve?
Yeah, I mean, the dealer is reaching out to the lender through the email,
You're talking about this one?
the F, E and F.
Okay,
Mhm.
so you think it's because of this,
Mhm.
okay? Anybody else who has been doing process? Is there anything else within that talked to you to say it's processing?
Third sentence.
Which one?
System will be developed as a commercial product that will show, allow dealers hopefully low payments and then credit quotations file repairs, the whole thing.
The whole thing, okay. So this whole thing. That's a process. You're thinking it from several days to within a week. Is that the process improvement? Okay. All right. Let's
For
turn.
me,
Go ahead.
for me, it's the first paragraph. If you could show me in the screen.
Okay.
So currently, there is not a single commercial product exists.
Like
So
this.
means, yeah, it's split in different applications maybe.
Okay.
So it needs to be integrated.
So the process, think about it from a business point of view. That's what we're talking, right? What is the business type process? Let's not worry about the IT guys here. Right? Let's not worry about the system. What is the process? So when you say it's a process improvement, surely this is not an IT problem. This is a business problem we're talking. Tell us what else is talking to you that talks about the business process.
And it's about the workflows. So that's
Okay.
what
So that's what we talked about here.
it's
Okay.
about the workflows of getting the loan.
Mhm.
The customer comes to the shops for auto repairs and then applying for the loan. And
Okay. All right. So that's good. Let's talk to the other problem. Like it's so nobody said productivity improvement, so I'm going to skip that. Some of you say that it is a cycle time improvement. So talk to me about what is the cycle time improvement.
Reduce the loan approve time by vendors from several days to within a week.
Okay. So
It seems it reduces the cycle time.
you're saying it's this thing. Okay. That's talking to you for the cycle time. Anything else? Online, anything else talk to you for the cycle time?
Same as what she said right now.
All right. So let me ask you questions. Can anybody explain me what is the business model here for this business problem? What exactly they're trying to do it? What is the model they're trying to set it up?
You're going to get the loan for the repair room.
Getting the loan for the repair. Who is getting the loan?
The customer.
Okay. So customer is trying to get the loan. So let's play out the role, right? Let's say if I'm a customer, I'm going to a dealer to do what? My car repair, right? And I don't have the money. Walk me from there. Where are you talking about it? I don't have the money. I brought my car to the dealer to fix it. Dealer say it's $5,000. I don't have the money. What is the next step? I'm gonna get a loan.
Asking if they have the option of getting a loan.
Asking who? The dealer?
Yeah,
Yes.
So as a customer, I'm asking dealer, is there an option to do it? Then what?
So that's when.
Then
you
who
go-
applies for the loan?
So the dealer applies.
Customer.
No, the dealer, I think, on behalf of the customer, so he goes on to,
So the dealer applies on behalf of the customer
yes.
to lender. And then lender
approved.
approves or rejects it.
Yes.
What happens after, let's say he approves, what happens?
I believe that he'll notify the, the deal, and the dealer will have to notify the.
So from a business point of view. Right, if a lender agrees that he's gonna pay his money. Give me the loan. They give the loan to dealer to fix my car. Right, so dealer makes the money. Because they got the car fixed, they got their service. The lender makes the money because they got somebody to pay the loan. What's in for me as a customer? You got my car fixed. Right, so that's the business model. Now, how it's the money is making, who is making money here? Who is building that system?
The lender.
Is the lenders building the system?
No, the business.
The dealership.
The dealership is building the business?
Yes.
Look at the word. Agents will be responsible for signing a dealer shop and repairs. So dealer is not building the system. Who is building the system?
No, the,
Company.
The company is building. What are they doing?
So
They're creating a system. What's in for them? Why the hell they would create a system where the dealer and the lender are making money?
because then they will have to pay the money in order to use the system.
Okay, so they're gonna be a clearinghouse, sort of, right? So the dealer comes in. Right, and they have lender comes in, and then every time they perform the transaction, the R1 makes money. Right, that's why they're building it. Okay, so who is the business here? Dealer, lender, customer, or R1? R1 is that, right? So whose problem we are solving?
So the customer, actually all three, the customer, the builder.
Who's gonna pay you a check to build the system? Okay, so I'm gonna play the scenario. Okay? I want to build a house. But I want Herschel to pay the check. I'm gonna own the house. It's for my benefit. Is Herschel gonna be happy?
No,
Is the builder gonna worry about me telling something? Or builder is gonna worry about what Herschel says because Herschel is paying the check?
what are children's?
So whose problem in this scenario you're trying to solve? Dealer,
Dealers.
lender, R-flow, customer? Who is paying the check?
Customer.
Why do you think it's a customer, Nicole?
Because the customer is gonna,
Is customer building the system?
no, it's gonna pay back, after.
No, I
the
understand.
lending of money.
Is who is building the system? Who is paying? If I'm a IT guy who is building this system, who is paying my check?
R-Flon is
Okay, if R-flow is paying check, who I'm gonna listen to? Problem I'm gonna worry about solving. Okay. So we all agree, right? This is R-flow's problem that we need to solve. What is R-flow's problem?
They need to reduce the loan time. So they don't have like proper system to manage the loan process.
All right, so let's talk one at a time. You said they didn't reduce the loan time. What is the current loan time?
Several days.
Where did you read that loan time is several days?
It's in the last sentence.
Okay. Can I do this now? Okay. Right, let me try to use this thing. What does this statement tell me?
There's no competition.
So if the product doesn't exist, is there a cycle time exist?
No.
No. There's a certain type of operations that are going like initially, originally, but it has to have.
Look at it from Mr. Harflon's point of view, Mr. and Mrs. Harflon's point of view. Is there a cycle exist today? That I'm trying to like it's improved?
No, there's no competition.
There is no product, there is no cycle.
Nothing exists.
It doesn't exist, right? So can I say I'm gonna worry about cycle time? No, right? So I'm not gonna worry about it. All right. The other thing is process improvement. What process?
Can I ask you a question?
Yes?
It says there is no single product. So that it doesn't mean that there is no product at all, right?
There is no single product. Look at that. Whose view we are looking at it? Our flow. Does our flow has a product? It's not saying that there is no product exists in the market. Looking at it from our flow point of view, I don't have a product in my portfolio that exists that allows me to do that.
Gotcha.
Right? All right, let's go to process improvement. What process I'm improving for our flow?
Working develop, finance, auto repair.
Is that a process exists today?
Providing the loans to the clients.
Is that my business problem or it's a dealer's business problem? What is my business problem? That's this important thing. Who is the business?
To me,
Who is paying it?
to create the system to.
Right. So do I have a cycle? If I don't have a product, do I have a cycle? No.
No.
Do I have a process if I don't have a problem? I don't have a product, so I can't have a process. Okay. Is there a productivity?
No.
There's no productivity. Is there a cost? I don't have a product. I don't know what the cost is. What I'm doing,
Creating the client base.
there is no customer, there's no product. I'm building a new product to create a new market for me. What is my current share? 0%. Once I deploy this my product, what is likelihood? Greater than 0%. Right?
Yeah.
So what I'm doing. Do you guys agree?
It's still kind of confusing for me.
Tell me what's your confusion?
The key is applying the.
Yeah, I think that is, yeah.
You have to think, we all read, so here is the rule number one, the skill or not the rule, the skill number one that all of you need to think about it. We all read the same paragraph, right? Did we all interpret it the same way?
No.
We had at least 3 interpretations, right? 8, 1, and 7 initially, or then now 8 and 7. At least 2 interpretations, which is completely different. You're going to face the same skill when you go in quality assurance world. You will be presented with the requirements. You need to make sure you understand it from your customer's point of view in their perspective. What that means, you're going to ask a whole bunch of questions. You have to make a whole bunch of analysis, right? What is the first thing we say? Default, you went to dealer, you went to lender, you went to customer. Whereas the actual person who's paying you to solve the problem and their need is the R flow. Right? So you need to think about perspective. Who is paying me and whose problem I'm solving it and what problem I'm solving. Okay. Are you with me?
Yeah.
All right. Okay. So that's part of the planning. You need to think about it. What is the problem you're trying to solve it? Whose problem you're trying to solve it? And what exactly they're asking to be solved. Okay. In that case, they were trying to ask it, get me a product into the market that will help me to solve this need. Okay. I'm going to walk through this pretty quickly. This is how the things works in a corporate world. Not most of you is going to get engaged on it. It's typically how the project gets improved. Okay. So when you start identifying this business problem, right, the next step typically happens in a big company, or even to this extent in a small company. they have only certain amount of money to invest, right? So they have to make a decision as when is the right time to invest, whether it's a valid business value or not, right? So typically you come up with what is the problem, come up with what is the solution that you're proposing, what is the cost, and how long it's going to take you, right? So 3 factors: cost, timeline, right? And the impact that it's going to do that. Once you do that, you put together and go to something known as the essentially business case approval committee or group, whatever that is. In a big company, it is both an IT representative and a business representative sitting in, looking at and validating it. And they have certain rules in terms of it. Any investment that you ask, it has to meet it within certain criteria, certain return, and so on, in order for them to invest the money. Okay, so you go through it, you're gonna go ahead and try to convince that group to give you the money to build the system. Right, you're gonna present your case, and based on the case, right, and based on the parameters that they say this, you're gonna look at it and say, yeah, it makes sense. We will invest it. It's timely. It's good. It has a value. It'll return the benefit that you're telling them. Or they can say, yes, we see the potential. I'm not convinced with the data. I want you to go re-examine based on this thing that I'm asking you to do. Right? It could be, can you reduce the time? Can you reduce the cost? Can you bring it to a broader set of problems so that there is a more return on value type of thing, right? And if they ask you, then you just say, hey, I need to adjust some scoping. I need to go do further analysis, get all the data and come back to you. So that could be another potential. Or third option, they just say, good, but it does not make a business sense to invest this much money when it takes at like 3 years to return it. I have other proposal that can return it in the money in 2 years. We're not going to return it. We're going to reject the project. And that's the end of it. Right? So if it goes through it, if it makes it through it, approval process, that's when you get the money and says, okay, now get into the next phase. What is the next phase after planning? Analysis phase, right? So you jump into analysis phase. So that's how typically it happens, right? Now, as a quality assurance person, typically you're providing input to understand the cost, how long it'll take it, and how long timeline it'll take it. But typically, whoever is the project manager or the development lead, who is usually taking the torch, because they have to fill out all of the other views into it before taking it to them. Just keep that one thing in mind. But that's how the process works. Go from a planning to analysis, right? The first thing that typically they do in analysis is try to figure out what is sometimes known as a requirements, right? So you're going to see the word requirements definition documents, or what are the requirements, which is nothing but if I want to build a house, what are my requirements? Does it need to have a single story, a multi-story? Does it need to be in an urban setting, or is it needs to be in like it's kind of whether in downtown type of areas, right? Does it need to have a backyard for the kids to play? Does it need to have a swimming pool? All nine. What are my requirements? What exactly I'm looking into that house when I build it, right? So that's what it is. A lot of times in the software world, it talks about what are the features or capabilities of the system that you're trying to build it, right? Going back to our example of the bookstore, I might be able to build a search capability, I could be indexing capability. I might be able to look at capability where I can see it across all the 4 stores. Those are some of the functions and features that I'm talking about, right? So what exactly the system functions that you're going to build it that's going to fulfill the purpose of the system? Like, why did you get the funding? What exactly business problem you're trying to solve it? And what features will enable you to solve that business problem? That's what this is about. Depending on how you write that document, right? You can write it from 2 people's view. You can write it from business user's point of view, which talks about here are the functions I needed. Or you can write it from a systems point of view and say, I want to have this capability, it needs to integrate with this system, and this system. Right? So depending on how you do it, you can call it a requirement definition document if it is focusing on customer view, because it's defining what the requirement is. versus you can do a requirement specification. It's specifying what requirement needs to be done and how it needs to be done. That's from programmer or technical staff point of view. What you're gonna find it more often is a blend of two rather than a one or two. Right? There's no best practices of what needs it. Every company has more or less kind of their template. But the goal is what capability are needed and how it's going to be built or where it's going to be integrated. Okay. Those are the kind of requirements. Now, when you take it requirements, you can categorize into two requirements. One is called a functional requirements, and the other one is non-functional. Functional is focusing on what are the capabilities going to be built, which is typically what input I'm going to provide to systems, what output I'm expecting from the system, what rules is going to be processed in the system. In this scenario where things doesn't go a happy path, the exceptions, what exceptions is going to be done, how it needs to be handled. Those are functional requirements. Then you have another aspect, which is a lot of times known as a non-functional requirements, which focuses on the, what we call it, scalability, right? What is the operationality for that? What is the security aspect? Who all can access it? From where they can access it? How long it needs to be up? Right? Is it 24/7 systems? Or is it only, hey, if I'm doing an hour flow, there's no 24/7 dealers that's going to come and require maintenance. Right? I may just say, hey, it needs to from 7 in the morning till 10 in the night because it covers 7 to 7 Eastern and Pacific board time. That's fine. Right? So what is the physical environment? Can you access from anywhere? Or does it has to be within the company network only? What are the parameters around it? Who are going to use it? Are the dealers using it? Are they trained? What skill level they have? What type of training I'm expecting it to provide them when they want to use this system? Is it self-intuitive? Right? All of those factors. What data, how it's going to be secure? What should be the response time? What is the uptime? Like its system crashes there? How long it should be down before it needs to be up? Right? For example, I've built a whole bunch of 911 systems in my past lives. There's no questions. You can't let it go down. You need to design it such a way that it's always up. Because people's life depend on it. Can't go down. Right? That versus if I'm building it like it's our flown system. What is the requirement? That one cannot go down ever. This one, it goes down to do that, right? Also, how many people will use it at the same time? Think about 911. What is the biggest failure was 911? Two instances I can remember, 9/11 and Katrina, Hurricane Katrina, right? Those two, 911 system couldn't hold the traffic, couldn't handle it. It was down. There was a lot of people's life impacted, right? So the requirements that I have it to define it in terms of what is the downtime, what is the mean time between failure. So this mean time between failures, if its system goes down, how long before it must be up? And how often it fails? All of those are characteristics. Is it 99.9% uptime? It's 100% uptime? What exactly is expected? Right? All of those specifications that you identify on behavior of requirements is known as a non-functional requirements. It is required for its operational ability, but not required to perform its business ability. Right? That's the key difference between functional and non-functional. So let's talk in the context of a quality assurance person, right? So who builds the requirements document? The business, right? Business persons working with potentially sometimes some IT people who help them to capture the information put into it, right? A lot of times, you know, something as a business analyst, right? They work closely with the business to pull together that document. But then you as a quality assurance person needs to go in and look it from a different lens. Okay, the first thing you do it is what I call it is as a quality assurance person, you need to apply 3C and T test. Okay, what 3C means is it correct requirement? Okay, when I say correct is, does it belong into this business domain that I'm trying to solve? Okay, if I'm building this our phone systems and I put in a requirement, something like it should meet all the HIPAA compliance. What does that has to do anything with the automobile? Nothing, right? So is it correct? Does it even belong in this problem space? Okay. Second aspect, is it consistent? So if I have same requirement put at 3 different places in the document, is it consistent? Or one it says, hey, my response time should be 2 seconds. The other one says response time should be no less than 5 seconds. Right? Or less than 5 seconds. That's not consistent. Is it 2 seconds or it's 5 seconds? What exactly you want? Is it consistent? That's what you need to look at it so that people don't give a contradictory requirement. Third thing you need to think about is it complete? So for example, if they say it should follow all financial regulations, which is within the scope, right? Because you're putting it a requirement, a system that is going to take people's credit application. And you say it should meet all the financial regulations as identified in Appendix A. But there's no Appendix A. Where do I look into that? Or if you just say needs to be government defined, well, can you tell me which site I need to look at it to get that? So that I can be much more crisper and clear what regulation system should meet, right? That's called a completeness. When people identify external references or internal references, are those there? Can you validate it? Can you round out the requirements? So that's the 3C part, right? No undefined references. All the desired things is present, right? All the links in all the document. They say, go to this site, but that site doesn't exist. Is that good for you? No, because you don't know what is they expecting, right? And again, correctness we talk about is it actually something for the customer, right? Don't give me something that none of the customer wants. What value it adds, and it doesn't even belong here. And all requirement needs to be verifiable or testable. Okay, so if I just say system should respond in a timely manner. Can you test that? If somebody says that, hey, your system should respond back in timely manner, what does that mean?
They're not being specific.
They're not being specific. Can you test it? You can, right? Versus if they say system should always respond back within 2 seconds. Now, can you test them? Right? That's a testable. It's not timely. Right? It's much more specific what timely means to them. Right? Because if I'm generating a report, a batch report, it doesn't matter 2 seconds. It can take it like 5 minutes, come back and send me an email. Is that acceptable? Right? That's the kind of questions you should be asking here. Is not only the requirement is consistent, clear, and complete, but does it lend to it that you can test it and you can say, yes, the system meets this. No, system doesn't meet it. If you can't say yes or no answer, that means there's a problem. You need some more information in order to say yes or no, right? For example, if you're building a house and says, should a house have a basement? So, it may have a basement. Well, what does that mean? You want it or you don't want it? Right? It's a yes or no. Because if you want it, then I need to make sure when I test it, is there a basement or not? If you don't want it, and if they're present in the basement, is that acceptable or not? I don't know. Okay. Then again, requirement needs to be traceable. So as you go through it, right, from all the analysis cycle all the way to the test, can you trace it, what they ask and when they ask, and how it related in the system? Right. Most of the modern day tools will essentially by default enables you that. So as you go from one phase of the software development to the other phase, it will automatically give you that connectivity. Okay. How do you collect the requirements, right? So there's a whole bunch of techniques that the user, the business analyst use it to that, right? The key thing for you is a lot of times you will be engaged to listen into those calls as they collect the requirements. And then they want you to, like, it's validated as they are getting collected and ask question if it is not clear to you, right? Because you, at the end of the day, are responsible to make sure the quality of the product meets the expectation of what the customers are, right? So there are a lot of different ways you can do it. Is essentially customer reactions. You can do an interviews. You can do a context-free diagrams, and we'll see some of those examples as we go through it. Okay. So we'll look through the definition document by an example. So here's the time to pause for the day. But before we pause, here are a couple of things I want you guys to do. Okay, so pull up your folder, the third tab. Remember I said the second tab was exercise. Third tab was there were 2 project documents. Okay, so that entire third tab, not the test one, the one before that. This tab, yeah, this tab. Okay. So the tab that starts with the requirement specification prepared for our form. That particular section. Okay, so for those who are online. Okay, under our flow project document. If you click it, there are 2 documents, the system design and requirement specification. Okay, those 2 documents, the first one and the third one is what you expect to read it. Start with the requirement specification document first, and then go to system design document. So the order is requirements and then design. Okay. So the number 1 is requirement specification document. Read that and then read system design document.
Where is the system design?
It's in the same one, it's
Oh, it's the
continuation.
same, okay.
So if you look at it halfway through
Halfway through.
it, so it's in the same tab, right? We intentionally put it everything into one tab. So you know everything between those 2 tabs is what you need to read.
It's after the revolving height, so you have to go a little more further out.
Okay. So those are the 2 documents. Yeah, so it's not-
This is the requirement.
Yes.
The other one is here.
Okay. Trust us, all of your folder has both the documents between those 2 tabs.
System design.
Okay.
You find it?
Requirement. System design.
So for online, it's 2 separate documents. For you, it's in the same folder. Back.
We have to go through whole thing.
Yes. So do you guys understand? You have found both the documents? All right. So this is what you need to do it between now and Thursday. Okay. We meet at 6:30 on Thursday on the Zoom. Doesn't need to be here in person. We'll be doing it that session through Zoom. You need to read these 2 documents in the order with the requirement specification first, and then system design. And then apply 3C and a T rule for everything that you read. Because those are the requirements document for the project that we just kicked off, the R-Flown project. That's the project we're going to use it throughout the session. What it is, it's the requirements document for that system that needs to be built.
Now, anything
Okay.
that you don't understand, make sure
Flag
you
it.
mark it down. Okay, and we can discuss on Thursday.
So 2 things, it's about 60 pages. Okay. I fully understand and fully comprehend the first time you're going to read through it, it's going to be like this. Okay. You're going to say, what is going on here? I didn't know. That's okay. Read it again. The intention is, do you understand what we're trying to do with here? And can you apply 3C and a T test? Says, if I tell you that you need to test a system which is built according to this requirement, can you simply say, yes, it meets the requirements, or no, it doesn't meet the requirement? Simple answer. That's what we are looking. Okay. Now, let me tell you, over the next 6 weeks, you're going to read that multiple times. And every time you read it, you're going to find something new that you did not notice it before. Okay. This is completely normal. That happens in the real life too. Right? So read through that document. Any questions that you have, saying, oh, it doesn't make sense here. I want to understand. Or it doesn't meet 3C and T, flag it. When we meet on Thursday, we're not going to talk new material. We're gonna spend those 2 hours answering any questions that you have it for those 2 documents.
So product consistent and complete, we are
Right.
And in the real life, they will throw you this type of documents when you start on a project. Okay, this is how it goes in the real life as well. You have to spend some time, maybe spend like whole 3 days, 4 days. Typically, this is a 37-page document, right? This is considered a mid to small size IT system. You have probably 100 to 300 pages document, which is pretty normal. Okay, in the real life. But you have to go through each, understand the functionality from the customer's viewpoint, how we are planning to build the system. Those are the requirements.
Yeah. Remember, we talked about 3 development methodologies, Agile, Waterfall, and that, right? Irrespective of what methodology you're following, right? So think about it. If you're focusing only on one iteration, all of the requirement for that iteration is essentially Agile. If you're thinking about a waterfall, everything they need to build a system, that's one review. Same thing with that, right? So don't worry about the methodology. What it is, the context, why we're trying to do it is your scope is this system. Read through it, understand it, flag any questions that you have. And we'll walk through those discussions on Thursday. Once you finish those discussions, you're going to gain a little bit more insight into it. You're going to end up reading it again before Saturday, and then we'll talk through it more on Saturday as we go through it. Okay? Any question of what is expected between now and Thursday from a work point of view?
So do we just document whether the 3 C's entity is applicable to whatever we do?
Right. So for example, like it says, hey, if I would have said that is system should respond in a timely manner. You look at that and says, wait a minute, I can't test this. Let me flag it. Let's talk about it. Let's get the clarity. What do you mean by timely manner? Is it 1 second, 2 second, 10 seconds? We'll talk through it. Right. But it's your way to flag it that, look, this thing doesn't meet the specificity that needed in order to do a quality job in testing it. That's what we are after. Right? Understanding of the system, understanding of what needs to be done. And then do you understand it, what you can do it to validate it or not, if it's working or not. Right? So if somebody gives you a system and somebody gives you this requirement and asks you a question, can you verify that system meets what is asked in this? Can you simply say yes or no answer? That's what I want to do. Okay.
And I'm going to send you 2 hour, or I think it's a 1.5 hour video as well. You can go through the video. First, read the requirement, go through the video, read the requirement again. I think that will help you understand a little bit further. Okay, it's a clarifications on the document.
Yeah, it's from one of the previous sessions.
One of the previous sessions we had for the discussion, so it will clarify for you. Okay.
I have a question. Between now and the next class, can I email? Yeah. Can I email like
Yeah.
the same email that you are sending the link?
Yeah, so here's what I would recommend, right? As a Herschel did, I would read it first. I will watch the video. Right? Video will give you insight for that. If you still have question after that, by all means, send an email to me and Herschel. On that email, send it. Right? Make sure you copy both of us, right? Depending on the work, like whoever will get first, we'll get back to you first. Right?
And it's the same email for the access as well for the Google Drive, right? Like if I'm not able to access a file or something?
I would say go and try it now. I mean, since you have a link, make sure you save the link.
Yeah.
As well. I think I already sent in the email to everybody. Hopefully,
Okay.
if you are not receiving email from me, let me know. And
Yeah, that will be a
I
problem.
just want to make sure, yeah, because we
Check
communicate.
spam folder to make sure it's not gone there.
Yeah. But
Thank
you
you.
always link, and I think the same information for the homework, you will be getting in the link as well today, by end of the day.
And also, if you want to rephrase it, some of things, what we talked about it, this is getting recorded. This session. I'm going to pause now. Everybody's good.
Yeah.